हम स्टार्ट हुए थे फ्रॉम लो अर्थ ऑर्बिट। लो अर्थ ऑर्बिट की क्या कंडीशन थी? लो अर्थ ऑर्बिट की कंडीशन थी 0 to 2000 किलोमीटर्स। ये बात हमें पता है, राइट? फिर हमने देखा दैट फ्रॉम 2000 to 36,000 हमने इसको क्या कहा था? वी कॉल्ड इट द मिड अर्थ ऑर्बिट। समझ आ रही है बात? लो अर्थ ऑर्बिट 0 to 2000, मिड अर्थ ऑर्बिट MEO फ्रॉम 32,000 to 36,000। क्लियर? अब हम देख रहे हैं कि वाई वी यूज दिस मिड अर्थ ऑर्बिट। ये MEO हम यूज क्यों करते हैं? MEO यूज करने के जो रीजंस हैं, उसका वन ऑफ द मेजर रीजंस इज द नेविगेशन सिस्टम। जो आपके फोन में गूगल मैप्स चल रहा है, इट इज ड्यू टू दिस नेविगेशन सिस्टम सैटेलाइट्स इन द मिड अर्थ ऑर्बिट। ओके, जो गूगल मैप्स हम रोज यूज करते हैं ऑलमोस्ट, और अपना सारा डेटा गूगल को गिफ्ट कर देते हैं, उसमें दिस इज द सैटेलाइट दैट इज बीइंग यूज्ड। अब हर कंट्री का अपना अलग नेविगेशन सिस्टम है, राइट? सो लेट्स टॉक अबाउट दैट। इसमें सबसे फेमस सिस्टम जो जीपीएस ही है, राइट? जीपीएस ही नाम पड़ गया है उसका, ऑल्दो जीपीएस इज नॉट द एक्चुअल नेम। व्हाट इज द एक्चुअल नेम, हम नेक्स्ट स्लाइड में देखते हैं। जीपीएस इज द सिस्टम ऑफ यूएसए। इसका जो एक्चुअल नाम है वो नैवस्टार है, नेविगेशन सैटेलाइट कॉन्स्टलेशन, नैवस्टार। दिस इज द अमेरिकन सिस्टम ऑफ जीपीएस, और ये बात अगले स्लाइड में लिखी हुई है, सो यू डोंट नीड टू नोट इट डाउन। अमेरिकन सिस्टम इज नैवस्टार। हाउ नैवस्टार वर्क्स वील सी राइट नाउ। उसके बाद ग्लोनास है। ग्लोनास इज द रशियन सिस्टम। गैलीलियो, this is the name of the European Union system, and it is said that it is the most accurate one now. Although इतनी डिटेल आपको याद करने की जरूरत नहीं है, but GPS of USA या Navstar of USA, GLONASS of Russia, Galileo of European Union. Then China has two systems. One is BeiDou 1 and one is BeiDou 2. BeiDou 2 is the more important one because it is a global system. ग्लोबल मीन्स व्हाट? ग्लोबल मीन्स के पूरी अर्थ को कवर करेगा। जैसे जीपीएस कवर द एंटायर अर्थ, अमेरिका ने बनाया है, बट आपको अपने घर के बाहर की गली भी जीपीएस में दिखेगी। सो इट इज अ ग्लोबल सिस्टम। बीडू 2 और जस्ट बीडू इज चाइनाज ग्लोबल सिस्टम। नाउ देयर इज अनदर टाइप ऑफ सिस्टम। द अदर टाइप ऑफ सिस्टम इज कि मान लो दिस इज द अर्थ, ये है आवर डियर कंट्री इंडिया, ठीक है? So if we can put only the navigation around this, मतलब हम बस यहाँ की एक नेविगेशन सिस्टम बना लें कि उसमें सब कुछ यहाँ का तो दिख जाए, बट यूएस में, यूरोप में क्या चल रहा है, उधर यूएस में क्या चल रहा है, ये सब ना दिखे, तो ऐसे सिस्टम को हम क्या कहेंगे? दिस विल बी कॉल्ड अ रीजनल सिस्टम, बिकॉज इट इज स्पेसिफिक टू अ पर्टिकुलर रीजन। अगर हम ऐसा सिस्टम बनाएंगे विच इज टॉकिंग अबाउट द एंटायर अर्थ, पूरी अर्थ कवर कर रहा है, तो उसको हम कहेंगे ग्लोबल सिस्टम। तो चाइना के पास दो सिस्टम है, एंड द मोर इंपॉर्टेंट वन इज बीडू 2 विच इज अ ग्लोबल सिस्टम। ओके, तो हमने ये देख लिया, जो बीडू 1 है, द अर्लियर वर्जन वाज ओनली अ रीजनल सिस्टम। चाइना का जो बीडू 1 था, दिस इट वाज ओनली अ रीजनल सिस्टम, एंड इट वाज डूइंग इट इन सेंट्रल एशिया, एंड इट वाज आल्सो कवरिंग अ पार्ट ऑफ इंडिया। This was their regional system, but now as their economy has grown and they have expanded, they are now moving on to a global system. Now, then we talk about India's system. India's system is called NAVIC. NAVIC stands for Navigation with Indian Constellation. We will see this system also in detail. NAVIC, also known as Indian Regional Navigation System. ठीक है, तो ये जो नाविक है, दिस इज अ रीजनल सिस्टम बाय इंडिया। मतलब ये सिर्फ इंडिया एंड इंडिया के अराउंड कुछ रीजन्स कवर करता है। एंड देन देयर इज QZSS, फुल फॉर्म इज नॉट इंपॉर्टेंट, दिस इज आल्सो अ रीजनल सिस्टम मेड बाय जापान। सो दीज आर द few regional systems and global systems of navigation, right? we are using which satellites here? We must be using geosynchronous satellite or geostationary satellite, right? Because it's in the mid earth orbit ना. एंड आप समझ भी सकते हो, अगर ऐसा सिस्टम बनाना है तो एंटेना के साथ जो अलाइनमेंट है इट हैज टू बी लाइक दिस, ताकि रीडिंग हो सके. कैसे होती है वो मैं बताऊंगा, बट इट कैन नॉट बी डन एट अ लो अर्थ ऑर्बिट लेवल. आई होप यू आर अंडरस्टैंडिंग, बिकॉज एट लो अर्थ ऑर्बिट satellite is moving very very quickly. All right, okay, now let's talk of first India system navigation with Indian constellation. All right, it has 7 satellites. 4 are geosynchronous, 3 are geostationary. Okay, 4 are geosynchronous, 3 are geostationary. अब इसमें एक और डाउट भी था कल, वो मैं अभी बता देता हूँ कि अगर हम ऐसे अर्थ बनाएं, एक के जियोसिंक्रोनस ऑर्बिट बनाएं, एक के जियो स्टेशनरी ऑर्बिट बनाएं और एक के जियो सिंक्रोनस ऑर्बिट बनाएं, तो ये तो क्लैश नहीं हो जाएंगे. ऑफ कोर्स देयर आर सम कॉमन पॉइंट्स ऑन दोज ऑर्बिट्स, बट द ऑर्बिट इज वेरी बिग. इट्स नॉट अ लाइन, इट इज सो ह्यूज कि अगर आप यहाँ पे 10,000 सैटेलाइट भी डाल दोगे तो भी इट्स नॉट गोइंग टू हैपन. आप सोचो इक्वेटर इंडिया का कितना, इक्वेटर अर्थ का कितना बड़ा है, ये इक्वेटर का भी एक्सपेंशन है. आप अगर इफ यू मेक अर्थ अ बिगर सर्कल, देन जो इक्वेटर बनेगी उतना बड़ा है ये और उतना ही थिक है, राइट? सो यू डोंट, इट्स नॉट अ सिंपल लाइन, सो द कोलिजन्स डोंट हैपन. बट ऑब्वियसली दिस स्टेशनरी ऑर्बिट, जियोस्टेशनरी ऑर्बिट विल बी मोर क्राउडेड, राइट? यहाँ पे ज्यादा सैटेलाइट डलेंगी relative to geosynchronous. Why? Because there are many geosynchronous orbits. This is also a geosynchronous, this is also a geosynchronous orbit, right? This is also geosynchronous orbit, this is also geosynchronous orbit. So there are many geosynchronous orbits, किसी भी एंगल पे हो सकते हैं. Stationary is one, so stationary orbit is more crowded, but clashes don't happen. Okay, now India again, it has put 4 satellites in geosynchronous, 3 satellites in geostationary. What is the coverage of our regional system? It covers entire India and it covers 1500 kilometers from our border. So अगर हम India, and by the way if you want to learn how to draw India in your mains, I am teaching you that now. बहुत अच्छा नहीं बनाना होता, but you draw 1 3 like this, 1 3 like this, and you link it. ये बन गया हमारा JNK. Then you draw one straight line, go down, this is Rajasthan, and then you make this for Gujarat. Then again you draw a line for Maharashtra. This is done. Then you draw here. ऐसा आप बना के you make a box for Nepal, 1 box for Bhutan, and 1 box for Bangladesh. Then you connect here, and slightly curved line से you connect here. It's done, and this is a decent enough map for mains, because you have to do this in 15 seconds. Okay, तो जो हम बात कर रहे हैं यहाँ पे IRNSS की, नाविक की, ठीक है? तो it will cover what part? It will cover entire India, पूरा इंडिया इसने कवर कर रखा है, and whatever from our border 1500 kilometers it is covering. Why? For safety purpose. वो कैसे होता है, क्यों हमने ये बनाया, हम अभी नेक्स्ट स्लाइड्स में डिस्कस करने वाले हैं. सो इट इज अ रीजनल सिस्टम. ओके, ऑलराइट. नाउ अब ये न्यूज में है नाविक, क्यों, उसके बारे में बात करते हैं. सो जो सेंट्रल गवर्नमेंट क्या कह रही है, इट इज सेइंग टू स्मार्टफोन मेकर्स, टू पीपल हु मेक आवर फोन्स, इट इज सेइंग दैट इन न्यू डिवाइसेस you integrate the NAVIC system, not the USA Navstar system. And what are they saying? You must add the L1 spectrum band, which is part of the GPS. What are spectrum bands? Why L1 only is the GPS band? All of that we will see right now. Okay, हम आज ये spectrum bands, electromagnetic spectrum, हम ये सब देखने वाले हैं. Okay, so this part is clear to you. I hope there is no doubt till here. Okay, this is in the news NAVIC, that's why it's important. इस पे previous year भी आ चुका है. All right. तो अब क्या होगा? Once you do this, you will be able to use NAVIC in civilian sector. Okay, civilian sector में जैसे GPS को हम यूज करते हैं, वैसे हम NAVIC को यूज कर पाएंगे. So what will it do? You can track public vehicles, right? Let's say you have a GPS system of your own, and there is a bus. यू कैन ट्रैक दैट बस कि वो किस टाइम पे कहाँ जाती है, यू कैन मैप द रूट्स। आपको एक जगह पे इंडिया की, मान लो आपको दिल्ली की बात करते हैं, अगर दिस इज दिल्ली एंड देयर मस्ट बी सम पब्लिक नेट ट्रांसपोर्ट सिस्टम ना, हर बस का एक अलग रूट होगा। सो इफ यू हैव योर ओन नाविक यू कैन मेक दीज रूट्स, मैप इट आउट एंड रैशनलाइज देम, राइट? सो टेक्नोलॉजी व्हेन डेवलप्ड, that too developed indigenously for Indian conditions, always helps in saving money. ओके थोड़ा सा इकोनॉमी भी पढ़ाऊंगा मैं आपको आज। तो ये मैपिंग हम कर सकते हैं, दिस इज वन ऑफ द एप्लीकेशंस ऑफ नाविक, राइट? देन लेट्स से दैट वी सी थ्रू आवर जीपीएस और आवर नाविक सिस्टम दैट सम नेचुरल डिजास्टर और साइक्लोन इज फॉर्मिंग इन द सी। तो हम वार्निंग दे सकते हैं फिशरमैन को, right? We can track criminals also who are using the system through their phones etc. Again natural disaster information. तो इसके एंड अगर मान लो इसमें और वो आए, like let's say they ask you can GPS be used in banking services? तो yes it can be used because you can track the assets, you can track the vehicles that are carrying the money that take the money to the ATM, right? So when you are thinking about the uses of technology, think slightly broadly. Okay, जब आपको ऐसा क्वेश्चन है, ब्रॉड सोचना है अपने को, कोई आउटलैंडिश चीज नहीं सोचनी। अगेन नाविक कैन नॉट सॉल्व द यूक्रेन क्राइसिस, नाविक कैन नॉट मेक इंडिया एनर्जी इंडिपेंडेंट, आर यू अंडरस्टैंडिंग व्हाट आई एम सेइंग? बट नाविक मेक इंडियाज बैंकिंग सिस्टम बेटर? यस, आई होप यू नो व्हाट आई एम ट्राइंग टू टेल यू। तो जब ऐसे कोई टेक्नोलॉजी आए, स्पेशली इफ, और यहाँ पे 99.9% टेक्नोलॉजीज जो न्यूज में है, स्टैटिक में है, दे विल ऑल बी कवर्ड। सो व्हेन यू नो द टेक्नोलॉजी, थिंक ब्रॉडली। ओके, नाउ लेट्स टॉक अबाउट नैवस्टार। नैवस्टार इज सो पॉपुलर, जो ग्लोबल पोजिशनिंग सिस्टम है और नैवस्टार है, दे हैव बिकम सिनोनिमस, लाइक उनका सेम नेम हो गया है, लाइक दैट्स हाउ पॉपुलर दे आर, राइट? सो इन जीपीएस सैटेलाइट्स आर इन सेमी सिंक्रोनस ऑर्बिट। अब ये क्या होता है, आप वर्ड ब्रेक डाउन करो, आई हैव रिटन इट हियर, जस्ट डू द वर्ड ब्रेक डाउन एंड थिंक व्हाट सेमी सिंक्रोनस मस्ट बी। इफ जियोसिंक्रोनस ऑर्बिट is around 36,000 kilometers, okay, then what must be semi-synchronous? Semi-synchronous would be half of that, somewhere around half of that, doesn't have to be exactly half, अभी आपको बताऊंगा क्या है, but somewhere around half of that means somewhere close to 18,000. This is how you do word breakdown. मान लो आपको नहीं भी पता, you have not read it, you can relate it with कि हाँ, it is something similar to what was there before, something similar to our geosynchronous we know, so something similar to that is written here, so we can derive that it must be close to something like this. Okay, now इसमें कितनी satellites हैं? How many satellites does GPS have? It has 24 satellites. The distance is at 20,200 kilometers and it takes 12 hours to complete the orbit. अगर हम एक normal satellite लेते, it would take how many hours to complete the orbit? 24 hours. This would be a geosynchronous satellite. Geosynchronous. Correct? But मैंने क्या किया? I took the semi-synchronous orbit. If there were 24 hours and I had this were the satellite, तो अगर मैं उसका आधा कर दिया distance, तो how much now the duration of the orbit is going to be? Again half of that. This is the actual meaning of semi-synchronous. It was earlier covering in 24 hours, now it will cover in 12 hours. Okay, and for this they have used 24. This is the number of satellites. This actually, the more satellites you put, obviously it will become more and more informative, the system will become more and more correct. तो जैसे जो गैलीलियो सिस्टम है, तो मैं उसे why is it called the most accurate? Because it has 32 satellites. So since it has 32 satellites, it is said to be more accurate. All right. तो यहाँ पे 24 satellites have been put. 20,000 kilometer was the distance. All right. So completing the orbit in 12 hours. This is Navstar of US. Now how does it work? काम कैसे कर रहा है? कितनी भी satellites हो, but how is it working? This is the thing. So होता क्या है, जैसे ये अर्थ है, right? If you let's say what is happening is, I'll demonstrate here. This is the Earth's curvature. You are standing here. There is one satellite here, one satellite here, one satellite here. It is sending signal to your phone and receiving signal. Again, this is not the exact mechanism. I am just explaining. You don't need to understand this. ये एक signal भेजता है और receive करता है, right? Now this signal is sent in the form of light. But light की भी कोई particular speed है. And as we know, speed is equal to distance upon time. Okay? तो light की एक particular speed है. उस speed से ये signal आता है, उस speed से signal वापस जाता है. So that is happening at a particular time. तो इस signal को आने और जाने में there will be very small time delay. Let's say the signal comes to your phone in 1 nanosecond, goes back in 1 nanosecond. So here the signal will go at a different speed or it will be a different distance. Speed तो same रहेगी. यहाँ पर जो distance है वो different होगा, यहाँ पर distance different होगा, यहाँ पर distance different होगा. So 3 signals from 3 or 4 satellites, whatever is required, 4 satellites will send their signal and then it will come back. So यहाँ पर एक different distance, यहाँ पर एक different distance, यहाँ पर एक different distance from your phone. So then they will calculate the time delay कि इतने को वापस आने में कितना टाइम लगा, इसको वापस आने में कितना टाइम लगा, इसको वापस आने में कितना टाइम लगा, राइट? टाइम हमें पता चल गया, स्पीड फिक्स थी, तो व्हाट कैन वी फाइंड? वी कैन फाइंड द डिस्टेंस कि यहाँ एट फ्रॉम दिस पॉइंट वेयर यू आर स्टैंडिंग, फ्रॉम सैटेलाइट 1 व्हाट इज इट्स डिस्टेंस, फ्रॉम सैटेलाइट 2 व्हाट इज इट्स डिस्टेंस, एंड फ्रॉम सैटेलाइट 3 व्हाट इज इट्स डिस्टेंस. So then from 3 satellites we will find that okay, this is the exact position of this like person who is standing here. This is the exact position. So this is what, this is the idea of trilateralization. 3 satellites से हम information लेते हैं, then we calculate signal testing and time delays. ये करके we do trilateralization. What do you need to remember here? Only the word trilateralization. इसके अलावा आपको कुछ भी याद करने की जरूरत नहीं है. बट इट वर्क्स थ्रू दिस. आई होप यू हैव अंडरस्टूड के सिग्नल आ रहा है एंड सिग्नल वापस जा रहा है, उसमें जो टाइम डिले है वो चेक करके हमें क्या पता चल रहा है? टाइम. स्पीड ऑफ सिग्नल इज स्पीड ऑफ लाइट एंड स्पीड इज इक्वल टू लाइक ओके, स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम. तो ये मैंने कैलकुलेट कर लिया, ये मुझे पता है, तो आई कैन कैलकुलेट योर डिस्टेंस फ्रॉम एनी अदर नोन पॉइंट. दिस इज हाउ जीपीएस इज लोकेटिंग यू. When you are moving, it is constantly, you know, interacting with the satellites above the earth and checking ke aapka like where you are exactly through the concept of time delays. Okay, all right. Now what are the applications of GPS systems? Application of GPS is of 2 types. एक है standard positioning which we are using Google Maps etc. इसमें अगर थोड़ी बहुत, let's say there is a 5 meter gap, मान लो 5 मीटर जहां वो आपकी लोकेशन दिखा रहा है और जहां आप खड़े हो उसमें 5 मीटर का गैप है. यू मस्ट हैव सीन दिस हैपन जब आपने उबर ऑर्डर करी होगी या आपने कोई खाना ऑर्डर किया हो, तो वो कभी कभी लोकेशन एग्जैक्टली नहीं लेता, बिकॉज हेयर वी आर यूजिंग स्टैंडर्ड पोजिशनिंग सिस्टम. इसमें अगर थोड़े बहुत गैप भी हैं तो काम चल जाएगा. बट द अदर सिस्टम इज द रिस्ट्रिक्टेड पोजिशनिंग सिस्टम. ये जो रिस्ट्रिक्टेड पोजिशनिंग सिस्टम है ये मिलिट्री सिस्टम है, राइट? अब मिलिट्री सिस्टम इज वेरी वेरी एक्यूरेट. It is exactly accurate. Because why? Because here we are tracking other countries' military as well as our military using these satellites. So it is a restricted system. You, if you want, till you have security clearance, आपको इस restricted positioning की access नहीं मिलेगी. Civilian positioning, standard positioning की मिल जाएगी. So now, why did we develop Navik? हमने क्यों मतलब इतनी मेहनत करी जब GPS बनाया था? That in Kargil war, we asked Americans that, you know, you give us GPS. You give us GPS so that it will be of use to us. Okay, so that we can use it in the Kargil war. But the Americans denied it. They said no. So at that time it was felt that civilian positioning, they will still give us every day because they need money for it. But restricted positioning, even after offering money, America might say no at some point, right? So we will need our own system. We will need self-reliance. At that time, what we did, we started the idea of Navik, and today Navik is used for restricted positioning only. And as we have read, if for civilian positioning, it is now started to be integrated, right? We had read that current affairs is there, that center is saying that okay, you have to integrate NAVIC. All right. So this was the reason why we had contemplated the idea of NAVIC. So NAVIC contributes to something called strategic autonomy. Now let's understand what this term means. Strategic autonomy, and ये काफी important है because बहुत ज़्यादा news में है, and our foreign policy is now constantly revolving around the idea of strategic autonomy. Let's say I am fighting a war in Kargil. I need restricted positioning. I don't have NAVIC. So what do? I can either talk to USA, or I can talk to Russia, or I can talk to Europe, or I can talk to China. Let's say USA says no. So what do? I go to the Russians, and the Russians say, okay, great, take it, no problem, right? Then what happens? I win the war. We won the war in Kargil. Then 2 years later, there is a vote in the United Nations General Assembly that should we expand the United Nations Security Council or not? Should we abolish the veto that is given to these 5 permanent members? Should the veto be abolished or not? This vote is happening in the General Assembly. At this time, Russia will come to us and say, vote no. And we will have to vote no. Because next time when war will be there, again we will need Russian satellite of GLONASS, right? So we don't have autonomy to make decisions in strategic matters. So the main objective of Indian foreign policy today is to achieve strategic autonomy. When we are autonomous, when we have the full authority to make decisions on strategic matters, only then we will become a real world power. Correct? Because if we have our own system, then we can tell the Russians that no, whatever vote is happening in the United Nations General Assembly, we will vote as per our own interest and not as per your interest, because we do not need from you anything so essential that we can undermine our interest. This is the idea of strategic autonomy, and it comes not only from foreign policy, but it comes from domestic policy, it comes from science and tech, it comes from economy, it comes from the environment. And this is why NAVIC is a great example if a question is there on strategic autonomy, which I am assuming it will be there in this year's mains. Okay. Now, what is the second application of GPS systems? The first one was navigation. What is the second application? The second application is timing. Now, you might think, what is, क्या ज़रूरत है, time दिख तो रहा है clock में. The exact time, what is the exact time right now in terms of even milliseconds, right? This thing is not known to you or me, and even in the computers it will be different. Millisecond में different नहीं होगा तो nanosecond में different हो जाएगा. There is no clock that we are having in our wrists or in our hand or in our homes that is exactly accurate, because these clocks are mechanical. How does a watch operate? A watch has certain gears like this, or rather like this. Okay, certain gears like this. Many gears are connected, and they are connected in such a manner that they are, when they move, 1 second passes, the second hand will move. This is how the mechanical clock works, that okay, one gear is interlocked with the other, they are moving in such a way that it causes the second hand to move. But mechanical clocks are not accurate. यहाँ पे कितनी problems है, friction हो सकती है, oiling proper नहीं है, battery नहीं है, and even if you do it digitally, if you measure time digitally, you will have to input into the computer what a second means. I hope you're understanding this. Computer को ये नहीं पता what a second means. You can tell it to count seconds, but you will have to tell it what a second means. So how do we find out what a second means? एक सेकंड कितना टाइम होता है, ये हम कैसे डिसाइड करेंगे? हम अब देख रहे हैं, बट हमने कैसे डिसाइड किया कि इतने ही टाइम पे सेकंड हैंड मूव करेगा, राइट? हम एक सेकंड को अभी के 4 सेकंड के बराबर भी कर सकते हैं, राइट? बट वी हैव टू कोऑर्डिनेट इट विद द अर्थ. अर्थ जितने टाइम में घूमती है और जितने टाइम में रिवॉल्व करती है, उससे हमें ये टाइम कोऑर्डिनेट करना है. सो नाउ हाउ डू वी डिसाइड व्हाट इज 1 सेकंड? फॉर दिस we use atomic clocks. What are atomic clocks? They use radioactive decay. What is radioactive decay? We will study when we study nuclear energy. ये कुछ ऐसे रेडियो एक्टिव एलिमेंट्स यूज करती है जैसे कि सीजियम, जैसे कि रुबिडियम, मैं यहाँ नाम लिख देता हूँ उनके, कंसेप्ट अभी नहीं बता रहा हूँ, जैसे कि सीजियम, रुबिडियम, इनमें जब ये इनके न्यूक्लियाई क्या है, इनका जो एटम है वो बहुत बड़ा एटम है, राइट, जैसे हमने जो एटम देखा था इट्स अ वेरी वेरी बिग एटम, तो सिंस एंड देयर एटम्स आर अनस्टेबल, सीजियम रुबिडियम इस तरह के जो एलिमेंट्स हैं इनके एटम्स अनस्टेबल है, तो क्या होता है, मान लो सीजियम एटम है, एवरी 1 second it will emit an electron and this time will never change since it's a chemical property. आप कोई भी सीजियम उठा लो वो 1 सेकंड में एक इलेक्ट्रॉन दे रहा है, तो then the time that is taken by a cesium atom to release an electron is called 1 second, right? आप हम उल्टा समझते हैं, मुझे नहीं पता सेकंड कितना होता है, तो मैंने अर्थ के रोटेशन रेवोल्यूशन से मैच करना है, तो आई टुक अ सीजियम एटम, आई सॉ कि इसका जो टाइम है इलेक्ट्रॉन निकालने का, दैट इफ आई यूज एज अ सेकंड, देन आई कैन यूज 60 seconds एज अ मिनट, देन आई कैन यूज 60 minutes एज एन आवर, एंड देन आई कैन यूज 24 hours इन अ डे. तो 1 सेकंड कितना होता है ये यहां डिसाइड होता है. देयर इज नो अदर वे टू डिसाइड व्हाट 1 second इज. नाउ एज यू हैव सीन इन जीपीएस सिस्टम्स, इवन ट्रैकिंग के लिए इट इज यूजिंग टाइम डिलेस. अब हम हर कंप्यूटर में, इन एवरी कंप्यूटर आई कैन नॉट पुट सीजियम, राइट, तो सीजियम रुबिडियम से हम बनाते हैं एटॉमिक क्लॉक, एटॉमिक क्लॉक की इंफॉर्मेशन देते हैं हम टू द सैटेलाइट, एंड देन द जीपीएस सैटेलाइट helps timing of all computers. It's very important that across the world the times of computers remain the same. अगर आप अपने कंप्यूटर का टाइम मैनुअली चेंज करके 2001 कर दो अभी, तो आपका इंटरनेट चलना बंद हो जाएगा. इट विल ऑलवेज से दैट यू डोंट हैव सेफ्टी सर्टिफिकेट्स एंड यू रिक्वायर अ सेफ्टी सर्टिफिकेट. You can bypass it and still access the internet, but there will be problems. So it is required that to the last nanosecond, the timings of computers around the world have to be same. That is done through cesium rubidium clocks to decide what 1 second is. But I cannot put a cesium rubidium clock in every computer. तो मैंने क्या किया, मैंने cesium rubidium clock से डेटा लेके सैटेलाइट को दे दिया और सैटेलाइट से वापस एंटेना से कंप्यूटर्स को दे दिया. So this is the second application called timing systems of GPS. Okay. Continuing the mid-earth orbit, what have we read so far here? We have read GPS and the various systems, the difference between global system and regional system. Regional का example IRNSS, global का example Navstar, and what is the differences and इसकी application क्या है, what is standard positioning, what is restricted positioning, what is timing, ये चीज हम पढ़ चुके हैं. अब हम देखते हैं कि और क्या क्या इसके पर्पसेस हो सकते हैं. जो जियो स्टेशनरी सैटेलाइट है, it is in a circular orbit at 35,786 kilometers. If I convert this into miles, it will be 22,222 miles. Okay. Sometimes in MCQs what they will do is they will put this figure as kilometers. तो ये आपको याद रखना जरूरी है. And sometimes they will put this figure as miles. 1 mile is 1.6 kilometers. Okay. ये होता है. So in this case you should know, right, कि माइल हमेशा छोटा होगा फिगर. ओके. 24 आवर का टाइम है इसका जियो स्टेशनरी का. इट इज मैच्ड विद दैट ऑफ द अर्थ. द डायरेक्शन ऑफ रोटेशन ऑफ अर्थ इज वेस्ट टू ईस्ट, सो द डायरेक्शन ऑफ रेवोल्यूशन ऑफ जियो स्टेशनरी हैज टू बी वेस्ट टू ईस्ट, राइट. दिस इज डन. MEO आपको समझ आ गया. सो हाई अर्थ ऑर्बिट इज दैट ऑर्बिट दैट इज अबव 36,000 के भी ऊपर है, तो दैट इज हाई अर्थ ऑर्बिट. इसमें जो मेन एप्लीकेशन है वो है लैग्रैंज पॉइंट. अब ये लैग्रैंज पॉइंट क्या होता है, फॉर दिस वी विल सी अ वीडियो. दिस इज अ वीडियो बाय नासा ऑन व्हाट लैग्रैंज पॉइंट्स आर.
Lagrange points. Lagrange points, named after the Italian astronomer who first proposed them, are places in our solar system where the gravitational pull of the planet and the sun and the motion of the orbit combine to create an equilibrium. So it takes very little energy to retain that orbit. Objects that are sent to these locations in space either tend to stay there naturally or can be kept there with minimal energy because the forces are in balance. NASA is taking advantage of those Lagrange points to send extraordinary missions like the James Webb Space Telescope, which will orbit the Sun at Earth Lagrange point number 2, allowing the telescope to stay in line with Earth as it moves around the Sun and retain that orbit using very little fuel. NASA's Lucy mission will study the pristine Trojan asteroids, the remnants of our solar system that have been gravitationally trapped around Jupiter's Lagrange point number 4 and Lagrange point number 5 for over 4.5 billion years. So, what are Lagrange points? They are places in our solar system where objects can orbit the Sun at the same speed as a planet, staying in the same place relative to both of them.
Okay. So basically हम इस वीडियो से क्या समझ आया? That Lagrange points are those points जहां पे the gravitational pull of the Earth, the gravitational pull of the Sun, and the motion of the orbit is in balance. For every planet, the gravitational pull will be different since every planet has different mass. Now, since every planet has different mass and the gravitational pull will be different, every planet has different Lagrange points. Okay, ये हैं Earth के Lagrange points. Earth has 5 Lagrange points: L1, L2, L3, L4 and L5. Right? These are the 5 Lagrange points of the Earth. जहां क्या है? Gravitational force of Earth, gravitational force of Sun and the motion of the orbit ensure कि इस point पे what is happening at this point, जो इधर force लग रहा है और इधर force लग रहा है वो बराबर है. तो ये point क्या हो जाता है? Stable. Right? If you want to put something here, you don't have to put an effort since it is stable. Right? तो ये है Lagrange point. These are 5 Lagrange points. Please remember their position. This is important that L1 is between Sun and Earth. L3 is on this side. L2 is here. So L1, L2, L3 are on the Sun-Earth line. L4 and L5 are not on the Sun-Earth line. Right? L4 ऊपर, L5 नीचे. ऊपर नीचे से फर्क नहीं पड़ता because it's an orbit. It's circular, so it doesn't matter. But Sun-Earth line matters and position matters. L1 is between Earth and Sun. L2 is this side. And L3 is here. Okay? All right. Now, high Earth's orbit has Lagrange points L1, L2. The distance of the Lagrange point is about 16 lakh kilometers from the Earth's surface. Okay? Satellite at this point, if I put a satellite at this point, right, it will also start orbiting like this. Okay? Now, this satellite can constantly monitor the Sun without the impact of a solar eclipse. If I put a satellite on L2, or let's say I put a satellite in Earth's orbit and I wanted to look at the Sun, it will be a problem. Why? Because this satellite के बीच में कभी Earth आ जाएगी, इसके orbit में कभी ना कभी एक point आएगा कि Earth आ जाएगी and it will not be able to look at the Sun directly. But at L1, it will have an orbit that is able to look at the Sun directly. So at L1, it is forming a halo around the Sun and therefore L1 orbits are called halo orbits. Right? These are 5 Lagrange points, forces are balanced, L1 पे halo orbit. Clear? Okay. There will be no impact of solar eclipse and satellite at this point can constantly monitor the Sun. Now, there are 5 Lagrange points in outer space for the planet of Earth. For Earth, there are 5 Lagrange points. Okay. If a spacecraft is placed on such points, it remains in a halo orbit. And the Earth and the spacecraft together will go around the Sun. जैसे हमने वीडियो में देखा था that the Earth is also going around the Sun and the object in halo orbit is also going around the Sun. Now, L1, L2 and L3, this is an important point. L1, L2 and L3 are in unstable equilibrium. They are in equilibrium. Equilibrium means forces are balanced, but they are unstable. L4 and L5 are in stable equilibrium. क्या मतलब होता है इन दोनों टर्म्स का मैं बताऊंगा. But सुन के बेटर लग रहा है स्टेबल इक्विलिब्रियम. स्टेबल मस्ट सीम लाइक अ बेटर थिंग, राइट? तो हमें आइडली सब कुछ L4 और L5 पे पुट करना चाहिए था. वी शुड हैव पुट ऑब्जेक्ट्स हियर, बट एवरीथिंग दैट वी डू इज मोस्टली क्लोज टू L1 एंड L2. व्हाई? देयर आर टू रीजंस. एक तो L4 L5 स्टेबल तो है इनका इक्विलिब्रियम, बट दे आर वेरी वल्नरेबल टू एस्ट्रॉइड्स कमिंग एंड हिटिंग देम, तो इसलिए नहीं पुट करते. एंड इफ समथिंग इज इन अ कंप्लीटली स्टेबल इक्विलिब्रियम, तो जब उसको वहां से हटाना होगा तो हम हटा नहीं पाएंगे. दिस थिंग लेट मी एक्सप्लेन टू यू. These are the three types of equilibrium. यहां देखो, in this case इस बॉल पे फोर्स बैलेंस्ड है, राइट, इट इज अ बैलेंस्ड फोर्स, बॉल कहीं जा नहीं रही, इट इज एन इक्विलिब्रियम जैसा लैग्रेंज पॉइंट पे है. बट अगर मैं थोड़ा सा भी पुश यहां दे दूंगा तो इट विल कम आउट. ओके, स्टेबल इक्विलिब्रियम में क्या है कि इफ आई गिव इट अ पुश इट विल गो लाइक दिस एंड कम बैक. तो जो L4 L5 है दे आर इन स्टेबल इक्विलिब्रियम. जो L1 L2 L3 है वो है अनस्टेबल इक्विलिब्रियम. दिस इज द डेमोन्स्ट्रेशन. थर्ड टाइप ऑफ इक्विलिब्रियम इज न्यूट्रल, राइट, कि आप थोड़ा पुश दोगे, जितना दोगे वो उतना ही जाएगी. अनस्टेबल इक्विलिब्रियम में द अमाउंट ऑफ पुश यू गिव एंड द अमाउंट दिस बॉल विल ट्रैवल इज नॉट द सेम. बॉल विल ट्रैवल मोर. तो हम फिर भी अनस्टेबल इक्विलिब्रियम में ही पुट कर रहे हैं चीजें. क्यों? बिकॉज एक तो जो स्टेबल वाले पॉइंट्स है वहां पे एस्टेरॉयड लगने का डर है. आई होप इतनी ज्योग्राफी आपको पता है कि एस्टेरॉयड क्या होता है. एंड दूसरा है कि अगर कोई चीज स्टेबल इक्विलिब्रियम में डाल दी मैंने सैटेलाइट में, मुझे कभी तो यहां से हटानी होगी ना. अब स्टेबल इक्विलिब्रियम में एक बार डालना तो आसान है, निकालना, गेटिंग इट आउट विल बी सच अ बिग टास्क. इट विल रिक्वायर सो मच फोर्स. सो इट्स बेटर टू पुट इट हियर, that if I want to get it out, I can get it out, and asteroid vulnerability is also less. So most Lagrange points that we are using are these points. Okay, all right. Now continuing the applications of high Earth orbit, right? We have read the first application, Lagrange points. Lagrange point pe we have put the James Webb Space Telescope. We will read that telescope in detail. Like that scientist from NASA was saying, like that ma'am was saying, कि हमने L2 पे पुट किया है JWST को, क्यों और कैसे वो हम देखेंगे. देन देयर इज जियोसिंक्रोनस ट्रांसफर ऑर्बिट. ट्रांसफर ऑर्बिट का क्या मतलब है? जियोसिंक्रोनस ट्रांसफर ऑर्बिट इज समथिंग लाइक दिस. इट हैज, एक तो है, दिस इज व्हाट, ओके, व्हाट विल दिस पॉइंट बी कॉल्ड? ए. ओके, लिख ही दी. आई राइट एवरीथिंग सो इट्स वेरी डिफिकल्ट टू आस्क यू क्वेश्चन. सो ऑन द पेरिजी हियर it is very close to the earth, but on the apogee it's very far from the earth. This is a geosynchronous transfer orbit. And why are we calling it geosynchronous? Because rotation here will be in sync with the earth. Why am I calling it high earth orbit? Because the highest point of this orbit is greater than 36,000. it is about 38,000. जो highest point है इसका वो 38,000 के आसपास है. So it will still be called a high earth orbit. Now can you think of any application for this? कि ये हम क्यों बना रहे हैं? Why do we need an orbit like this? Right? Geosynchronous and geostationary की applications were very clear. But here the idea is, if I put something here, if I put a satellite here, in this orbit at some point it will reach here, then here I can pull it back a little bit and get it to the actual geostationary orbit, which is at 36,000 kilometers. Something like this. अगर दिख नहीं रहा है तो मैं बना देता हूं यहाँ पे. In the first instance, what did I do? I put the satellite here, close to the earth. Then when it was rotating like this, here I acted on the satellite and said, okay, you come back here. And here you now start rotating in a geosynchronous orbit or geostationary orbit. The red one is where I wanted to go. The blue one is the transfer orbit, जो उससे थोड़ा सा बड़ा है, but I used it to get here. And why did I use it? कि फ्यूल बहुत कम लगेगा. अगर मुझे डायरेक्टली यहां से यहां डालना पड़ता तो it would take lot more fuel, a lot more energy, but this is a mechanical way of doing it with less fuel. So it is a geosynchronous transfer orbit. It is used to transfer satellites to a geosynchronous orbit. Okay, transferring satellites to a geosynchronous orbit, therefore called geosynchronous transfer orbit. This is also a high Earth orbit because इसका जो highest point है वो मिड अर्थ ऑर्बिट की लिमिट से ऊपर है, द हाईएस्ट पॉइंट. एंड इट इज वेरी हेवीली एलिप्टिकल. आई एम श्योर यू कैन सी, बहुत ही एलिप्टिकल ऑर्बिट है, राइट. द एपोजी इज समवेयर क्लोज टू 38,000. द एपोजी इज समवेयर क्लोज टू 38,000. द पेरिजी इज क्लोज टू 300, राइट. दिस इज यूज्ड फॉर इनिशियल लॉन्च ऑफ कम्युनिकेशन सैटेलाइट, राइट. एंड दिस विल कॉल, it will take much less fuel. So space agencies use this to maneuver a satellite for applications. Okay, for Mangalyaan mission, which was our mission to the Mars planet, we used this geosynchronous transfer orbit. How did we use it? यहाँ देखो, we put it first in the geosynchronous transfer orbit. Here we got the satellite to rotate around the Earth. After putting it into geosynchronous transfer orbit, I then got it to rotate around the Earth. Once it started rotating around the Earth, I got to 36,000 kilometers. Then I used a slight deviation to rotate it and put it in the orbit around the Sun. So first I put it around the Earth. पहले GTO 300-400 किलोमीटर पे बस आपने उस सैटेलाइट या उसको डाला. Then it goes like this. Now start going around the Earth. फिर Earth का जो orbit है, its orbit around the Earth was then leveraged. If you are, I hope you are able to see this. This was the initial thing where we have now put it here. From here I deviated a slight bit and put it around Mars orbit. So थोड़ा सा deviate करके I put it around the Mars orbit. Now once it goes around the Mars, then I put it into an orbit close to Mars, and then I put it on Mars. Right? So पहले I put it in the geosynchronous transfer orbit, then I put it in the geosynchronous orbit, then I put it in a heliocentric orbit. पहले geosynchronous और geosynchronous transfer orbit था when it was revolving around the Earth only. Then finally here at this step I made it revolve around the Sun here. So it was a heliocentric orbit. Then from heliocentric I put it into a Mars-centric orbit. Once I put it into a Mars-centric orbit, then I put it around Mars. तो मैंने यहाँ से वहाँ पहुँचा दिया, and the cost came only to be ₹7 per kilometer. बहुत ज़्यादा किलोमीटर नहीं obviously, but this is cheaper than taxis. Why? Because they were able to use geosynchronous transfer orbit. But there is also a risk here. Risk क्या है कि ये जो transfer maneuvers हैं from one orbit to the other, they are very very difficult maneuvers to do, because उस distance पे आपने अपनी satellite से communicate करके exactly उतनी energy देनी है कि वो एक से दूसरे orbit में shift हो जाए. This is a difficult maneuver to do, and this is why NASA does not use GTOs very often. NASA tries to go directly because इसमें risk नहीं है. If you go directly, fuel will be more, but the risk will be less. In this case, when you are doing something like this, कि पहले you put it around Earth, then from Earth you put it around the Sun, then from Sun you put it around Mars. This is a better picture for you to understand. पहले मैंने Earth के around डाला, फिर Sun के around, फिर Mars के around. यहाँ पे 2 बार ट्रांसफर करना है या rather 3 बार ट्रांसफर करना है, तो this transferring is a problem. Okay, so ISRO does this to save cost, but NASA does not do this because this transferring is a risky process. Okay, now how do you shift the orbit? On the satellite there is something called an LAM, or a liquid apogee motor. You just need to know what liquid apogee motor is. वहाँ लिखा है, but in the slide it will be clear. Liquid apogee motor पे you can use that to give energy. It moves from one orbit to the other, right? All right, this is done. Now we have read about satellites, little bit about satellites and orbits, right? Satellites क्या होती हैं, कैसे काम करती हैं, हम डिटेल में पढ़ेंगे. But before that we have to read about launch vehicles. हमने ये तो देख लिया कि हमें ऑर्बिट में पहुंचना है. How do I reach the orbit, right? How do I reach the orbit? This will be done through a launch vehicle. So now we will study about launch vehicles. I hope till here it's clear. Now launch vehicles are of two types. One is expendable launch vehicle, one is reusable launch vehicle. नाम से clear हो रहा है. Expendable means it will be expended, used, disposed. So it will be used only once for one mission. If I want to use it, I will use it once for one mission. इसका example है PSLV and GSLV. These are both expendable launch vehicles. Reusable means that I can use it multiple times. Okay. And now we are comparing the advantages and disadvantages of an expendable and a reusable launch vehicle. Expendable launch vehicle का क्या होगा? You put it into the orbit once, it delivers the satellite for you. उसने satellite deliver कर दी. Now you can't get it back. वो वहीं रह जाएगा. So it creates something called space debris. ये क्या होता है ये हम देखेंगे. First thing is I launched something. Rather let me just hold on. Okay. From Earth I launched some. Okay. So from Earth I launched a satellite like this. How will I launch it? I will use a rocket or a launch vehicle. Launch vehicle is nothing but rocket. I launched the rocket, it went to the geosynchronous orbit. Now in the geosynchronous orbit, the rocket delivered the satellite. Satellite यहाँ आ गई. Now what happens to this rocket? If I cannot get this rocket back to Earth, it will also stay here, right? अब ये भी orbit करने लग जाएगा Earth को, because orbiting is happening because of gravity. Anything that you put there will start orbiting the Earth. So this is the first disadvantage, that it will stay there. It will create space debris. What exactly space debris are, we will learn. Then you cannot use an expendable launch vehicle for a manned mission. Manned mission means what? Where you have to bring people back. If you have to bring people back, how can you use expendable launch vehicle? You have to use that rocket that can come back also, right? And India currently only has expendable launch vehicles. We are working to develop the reusable launch vehicle, because obviously this will be a much difficult technology to first reach this orbit, then come back also. Reaching is not that difficult. Coming back is very difficult, right? So India only right now has expendable launch vehicle. Reusable launch vehicle can come back to Earth. It can of course be used for manned missions also, because if you send astronauts, you can get them back, and it is reusable and it saves a lot of money. These are the advantages. But a basic hai, so I am moving on from here. Okay. Now, what are the major components of any launch vehicle like PSLV, GSLV? These are all expendable vehicles. They have certain components. First component is the engine. Then there will be a component called the fuel. Right? जैसे गाड़ी में होता है, गाड़ी is a launch vehicle for the road, right? Then there is a satellite, and there is a command and control system. So if in a car, right, in a car there is one engine, fuel, petrol or diesel, the payload is you, because you are the person who has to be delivered from one place to other, and there is a command and control system, that is the steering wheel, the gear, etc. So these four systems are there in a car, right? The same four systems are there in a launch vehicle, because the purpose is essentially the same. It has to deliver a payload from point A Earth to point B space using some fuel. So it must have an engine also. ये चार component होने चाहिए, right? Now in a car, okay, I made a lot of effort to explain this, but okay. So in a car, in the engine, right? In the engine, what is happening? There is a fuel. Fuel is petrol. It has to be burnt. Petrol has to be burnt to generate what? Energy. Okay. Petrol has to be burnt to generate energy. To burn anything in life, you require oxygen. You require oxygen gas. So oxygen gas is called, or any, let's say there is some other gas also that can cause this burning, that compound will be called an oxidizer. Oxidizer, because the most common oxidizer is oxygen. There is something called oxidation state also, but that is not important for you. So oxidizer is oxygen. Okay. Oxidizer is required to burn the fuel in the car. Fuel is petrol. Now in a car, what is happening? We are using fossil fuels. Fossil fuel like petrol, like diesel, they are carbon based fuels. You must have learned that they are carbon based. So in a car, when the carbon based fuel is oxidized, what is generated? First thing is energy, second thing is carbon dioxide. This is why cars are emitting carbon dioxide and causing global warming, right? So this is how a normal engine works. Similar process is there for a engine in a launch vehicle. A launch vehicle is nothing but, or launch vehicle or rocket is nothing but a car for a satellite. Okay. Now it has certain fuel, it has certain oxidizer. What is the fuel and what is the oxidizer? This we will now study. Now, on the basis of how this engine gets the oxidizer, oxidizer was in car engine oxygen. How this oxygen is obtained? On the basis of that, there are two types of engines. First engine is called non-air breathing. Second engine is called air breathing. Okay. First engine is non-air breathing. Second is air breathing. So can you do some word breakdown and think what this might be? What might be the difference? Air breathing is using the air in the atmosphere. Okay. And non-air breathing must have had the oxidizer with the fuel inside it. It is not concerned with what is there in the air. It will just use the oxidizer that is kept inside. Okay, it is close to the air. The second one is having some way to take the oxidizer from the air. This air breathing engine is nothing but scramjet and ramjet. And I'll explain now what it means. Dekho, the first system is non-air breathing propulsion system. Propulsion means to go forward. Oxidizer is used to burn the fuel. The oxidizer is not taken from the air, it is in the rocket itself. So if this is the rocket, there will be some fuel, there will be some oxidizer, they will mix and burning will happen. But this oxidizer to burn fuel will be added in the rocket itself. So it will increase the mass of the rocket. The rocket will now become more bulky, right? Because oxidizer also has to be added. But in this system, what is happening? Somehow it is able to get the oxygen from the air itself. How it does that, we'll just see. It's able to get the oxygen from the air itself. So if it is able to get the oxygen from the air, it is a lighter engine and a much better engine. Okay, all right. In a conventional engine, there is fuel and there is oxidizer and the compression happens. Now, why does compression happen? Agar मैं fuel, forget hydrogen, any fuel, if I have to burn with oxygen, one is I take air directly. If I take air directly to burn, let's say some fuel like petrol, I take air to burn petrol. How much percentage of air is oxygen? Only 21%. So if I take 100 ml of air, I will only be getting 21 ml of oxygen. But if I compress the air, or if I have some way to ensure that more air molecules or atoms are fit in this 100 ml, then more oxygen atoms will be fit in this 100 ml. Then if more oxygen atoms will be fit in this 100 ml, more oxygen will be delivered for the fuel and better energy will be generated. So if I can compress the air, I will get more oxidizer at the same volume. In the first case, air molecules were like this, and this was the oxygen molecule. In the second case, and this is the whole volume of the air. In the second case, I compressed it. When I compressed it, and this we have seen that air molecules are far apart, so we can compress them. When we compress it, it becomes something like this. So in the same volume, the number of oxygen molecules increase. So if I compress the oxidizer, if I compress the air, the burning will be even better, because nitrogen is not the oxidizer, carbon dioxide is not the oxidizer, only oxygen is the oxidizer, and I have to take it from the air. So either I have to install a filter, that cannot happen. So what I do is I compress, I take in much more air, so I get enough oxygen. This is the idea of compression. Now, you must have heard this term jet engine. Jet is a type of reaction engine. क्योंकि jet जब हमें हवा में दिखता है, हमें क्या दिखता है? That this is an aeroplane and some, like, something is being released from the back. ऐसा दिखता है ना, we see a stream in the sky. That is the jet engine is releasing something. So a jet is a reaction engine. It will take in air from one side, burn it, release air from the other side. If it releases air back, it will move forward. This is how it moves forward. This is a jet engine. Okay. This works on the principle of Newton's third law, which I'm sure you know, is every action has an equal and opposite reaction. So if there is one action in this jet engine to release the air back, there will be one reaction to move the jet engine forward. This is how a jet engine works. What we have to study is scramjet and ramjet. This is a jet engine. It takes air from this side, burns it here, and gives an exhaust. This exhaust generates a force. The reaction force moves the jet forward. Now, what is happening inside a jet engine? Let's see that. Inside a jet engine, there is fuel. We have kept some fuel. We have taken oxidizer from outside. Oxidizer is here air. But air is not the oxidizer. Oxygen is the oxidizer. To get more oxygen, I have done what? Compression. So I have compressed the air. I have gotten it here. If I have compressed the air, I have gotten it here. Here what is happening? Fuel plus oxygen is happening, or burning is happening, or another word for burning is combustion. So combustion is happening inside the jet engine. Then some gases are being released as exhaust, and this exhaust is pushing the jet engine forward. So it is called an air breathing internal combustion engine. Air breathing internal combustion engine. Got it? Now, we now move to what we actually have to study, ramjet engine. Okay, ramjet engine. Jet is clear. Jet ka idea is clear. Ramjet. Okay, now what does RAM mean? RAM does not talking about random access memory. RAM in English means to hit something really hard. I rammed the car into the pole. That is what it means to ram, right? So if this is some space and I ram into it, there was air here, I rammed into it. So what did I do? I compressed the air in between. This much air I rammed into the air, so the air got compressed. That is what a ramjet engine is. It rams into the air. Ramming into the air, it compresses the air. It takes the air in, then the compressed air is combined with the jet. Jet engine has what? Fuel. Compressed air is combined with the fuel, and what is done? Internal combustion. Then after that combustion, what happens? Gases are released backward. When gases are released backward, what happens? Thrust is generated forward. So a ramjet engine, right, is a air breathing jet engine, right? It is a air breathing jet engine with internal combustion. Okay, now you have to understand two things, or I'll make you understand here. This is what a ramjet looks like. It is moving in this direction. Sorry, it is moving in this direction. Here it is taking some air. It is ramming into the air like this. The air gets compressed. The compression happens. Now compression happens and then the air goes into the combustion chamber. Here fuel is released. Fuel plus air leads to generation of exhaust. Exhaust is thrown back and the engine moves forward. Now this is a ramjet. Now what is a ramjet in terms of speed? A ramjet works most efficiently at speeds which are supersonic. पहले आप ये concept समझेंगे कि supersonic क्या होता है, then we'll come back to the ramjet. Sonic speed. Sonic word comes from the word sound. Okay, so sonic or sound speed, if I say my speed is sonic, my speed is same as that of sound, which is 340 meters per second. Now yesterday night there was lot of lightning in Delhi. If you would have seen the lightning, or if you have seen lightning anytime, you see the light first and thunder you hear later, right? You see the light first and thunder you hear later, because light travels at a speed of 3 into 10 raised to power 8 meter per second. This is the speed of light, right? 3 into 10 raised to power 8. So 8 zeros after 3. And what is the speed of sound? 3 into 10 raised to power 2 meter per second. So since the speed of sound is much less than speed of light, when lightning happens, you will see the lightning first, hear the thunder second. Now this is sonic speed. If I am moving above this speed, I will be what? Supersonic. So if a jet engine can move above the speed of sound, faster than the speed of sound, it is called supersonic. Here we get a concept called Mach number. What is Mach? Let's say your speed is 2 times that of the speed of sound. So what will be your speed? 2 into 340, which will be 680. This is your speed. This will be twice the speed of sound. So you are in what category now? You are in supersonic category, and your Mach number here will be 2. So the multiple with which you are going at the speed of sound, how many times faster you are going than the speed of sound, is your Mach number. MACH, Mach. Okay, Mach number का मतलब है कि मैं इतने time faster जा रहा हूं than the speed of sound. Mach number is this. Now this Mach number tells you how fast you are. So in a ramjet engine, एक और चीज हम समझेंगे, then we'll understand Mach number properly. ये ramjet engine है, कैसे कर रहा है? It is ramming the air, compressing the air, getting the oxidizer inside, then burning. अब मुझे बताओ, जब ये स्टार्ट हुआ होगा, जब ये 0 किलोमीटर पर आवर या 0 मीटर पर सेकंड से स्टार्ट हुआ होगा और ये यहां चला होगा इतना सा, बस इट स्पीड इज राइट नाउ 5 किलोमीटर पर आवर, इट हैज जस्ट स्टार्टेड. तो इस टाइम पे, एट दिस टाइम, will it be able to get oxidizer from the air or not? At 5 किलोमीटर पर आवर, at very slow 5 किलोमीटर पर आवर, तो आपको पता ही है ना कितना है, at 5 km per hour, will it be able to get air from, it will be able to get oxidizer from the air or not? Just tell me that. Of course, no. It needs to compress the air. It is a ramming jet. यार 5 किलोमीटर पे थोड़ी एयर कंप्रेस होगी, जब ऐसे जाएगा तब एयर कंप्रेस होगी, तब कुछ बढ़िया होगा. हाँ, 5 किलोमीटर पे there will be some compression. Yes, very little compression will happen, but that is not sufficient to burn the fuel that is inside. So what does this mean? This means that there must be an optimal speed. There must be one speed at which we can say that at this speed it works perfectly. And the second thing, to reach that speed, it will need to carry some oxidizer. Some oxidizer will get it to that speed, right? Some oxidizer will be there that will get it to its speed. Let's say its optimal speed is Mach 3. What does Mach 3 mean? 3 times speed of sound. So its optimal speed is Mach 3. To get to Mach 3, it will use an oxidizer. After that, it is sorted. So it has very little oxidizer just to get to Mach 3. At 5 km per hour, it is also compressing the air, but the air is not sufficient to run it. So this optimal speed is the idea of ramjet engine. In a ramjet engine, you require an optimal speed. Now, in a ramjet engine, air will be entering. Now, the optimal speed is Mach 3. So if you are moving forward with Mach 3, 3 times speed of sound, air is also entering at 3 times speed of sound. Now you must have the technology to have this fast air be used also. अगर air एकदम झटके से निकल जाए, if it goes by really fast, you will not be able to burn the fuel properly. So again, there is an optimal speed at which all of this operates properly. In a ramjet engine, the optimal speed is between Mach 3 and Mach 6. Between M3 and M6, it works perfectly. Why only M3 and M6? Why only M3 and M6? This you don't need to know. This is the concept of shock waves and shock cones. Okay, it's written in the slide if you want to read it, but I don't recommend it. If you want, we can explain after today's class is over. In the last 30 minutes, I can explain this, but it's absolutely not required. Okay, so Mach 3 to Mach 6 is the ideal speed of a ramjet. Okay, now, why is this the ideal speed? If I just give you a hint, beyond this, it is not able to stop the air. The compression of the air that is happening beyond this, it is not able to use that air effectively, right? Okay, so it cannot work if the compression of the air is happening at supersonic speed. Just understand what I'm saying. The compression must be slow. Air can enter at whatever speed it wants, but the compression must be slow so that it is used effectively. This is a ramjet. So what do we know about a ramjet? We know that it is an air breathing system, air breathing. It works at speed Mach 3 to Mach 6. This is the ideal speed. Beyond this speed, it cannot work because it wants the compression to happen at lower speed. If air is compressed at faster speed than this, it will not be able to work. This is what we know about ramjet. What do we know about supersonic? We know supersonic is greater than Mach 1. Mach 1 is sonic, 1 times faster than sound, matlab 1 into sound speed, same sound speed. Anything greater than Mach 1 is supersonic. Now there is another term called hypersonic, which is very much in the news because of use of hypersonic missile. So I am also teaching defense here, right? Hypersonic. This term means Mach 5. If you are 5 times faster than the speed of sound, then you will be called hypersonic. So a hypersonic missile minimum has to be 5 times faster than what speed of sound is. Speed of sound is 340 meters per second. So for a missile to be hypersonic, the minimum speed required will be 1700 meters per second. Okay, this is the minimum speed of hypersonic. Mach 5. Now in a ramjet, the ideal speed is Mach 3 to Mach 6. So it is not, it can be called hypersonic, but just the starting of hypersonic. Okay, so it is ideally a supersonic engine. It can go to hypersonic speed, but not sustain there. right? It can operate up to speeds of Mach 3 to Mach 6. Here it is written that it will require an assisted takeoff. Why will it require an assisted takeoff? Because it will need to reach that particular speed at which it can use the air for oxidation. All right. Why was above Mach 3, above Mach 6, why was the ramjet engine not working? It was not working because it could not work if the compression of air was that fast. So the ramjet, an engine that was ramming air and working on the principle of jet, had a problem that if the air was compressed at supersonic speed, its combustion was not optimal. ये बात समझ आ रही है ना कि बहुत ज्यादा तेज एयर हो जाती है तो एक लेवल से ज्यादा इट कैन नॉट सस्टेन. सो व्हाट डिड आई मेक? आई मेड अ scramjet. I added this ability of supersonic combustion. So scramjet stands for supersonic combustion ramjet. What will this do now? It is a variant of ramjet. Combustion is taking place at supersonic airflow. Supersonic airflow is written, not supersonic speed. Supersonic speed पे तो ramjet भी चल रहा था. Supersonic airflow, even if the air is very very fast, it can combust. So it will be able to move at much faster speed. So a ramjet has even faster speed. A ramjet can move even at 8 Mach. So a ramjet is a scramjet can move at 8 Mach. So a scramjet is a proper hypersonic engine. Here it is written why it can do so, because of shock cones and shock waves, but it's not required. If you want, you can read from here. Scramjet can work even at Mach 8. So if I want to make a hypersonic missile, now hypersonic is just not Mach 6. I want to go beyond that. I want to be even faster. What will I use? Scramjet, supersonic combustion ramjet. And I hope you will never forget this now, because you know why the word supersonic combustion is there. Okay, this is a scramjet engine. Scramjet, air is entering, combustion can happen even at high airflow. Combustion happens here, thrust is released, and it will move at the speed around Mach 8. Okay, concept is clear? Now, next thing is solid fuel ducted ramjet technology. This is in the news this time. Solid fuel ducted ramjet technology. What is solid fuel? We will see later. But ducted ramjet technology should be clear. Now we know what ramjet means. So it is a missile propulsion system that includes a ducted rocket. Ducted means it has a duct like this, a pipe like this, right? With a reduced smoke nozzle-less missile booster. This detail you can read. This is the only thing you need to read now from the current affairs, because the concept is clear to you, right? It has a duct. It has a thrust modulated duct, means force modulated duct, and a smoke nozzle-less missile booster. It releases less smoke. It has a duct. It is a ramjet engine used for missile propulsion. It was made with an Indo-Russian R&D project. It has a solid fuel. Solid fuel, I know. Air breathing, I understand. Ramjet engine. And its ideal range is 70 to 340 kilometers. Why is this range not starting from 0? Why is this range not 0 to 340 kilometers? Because for ramjet to work, certain speed will have to be there, right? So minimum it can travel 70 kilometers. It is a missile propulsion system. Same technology I am using in missile. Missile is what? Missile is a car for a bomb. Rocket is car for a rocket. Car for a satellite. It is a launch vehicle, or a rocket is a car for a satellite. A missile is a car for a bomb, right? So this is what is in the news, solid fuel ducted ramjet technology. And since ramjet is in the news, since there is chance of it asking, that is why I have explained ramjet and scramjet in detail to you. There is one third technology called dual mode ramjet. This means nothing. It means that it has two modes. At Mach 4 to 8, which is the ideal speed of a scramjet, it will become scramjet technology. Below that, it will become ramjet. How it does that is not important. So it can work in subsonic and supersonic combustion modes. Subsonic and supersonic combustion modes, not subsonic and supersonic speed. I hope you understand the difference. When the ramjet was working, it was going at the speed of Mach 3, but the combustion was not happening at Mach 3. Combustion was happening at Mach less than 1. That is why it could not move beyond Mach 6. When scramjet was there, it developed the ability to combust at Mach more than 1. So it could move even at Mach 8. And dual mode ramjet can do both. let me just explain ramjet and scramjet again in 5 minutes if it is not clear, फिर हम उसके बाद चलते हैं आगे, ठीक है। जो solid fuel ducted ramjet है उसमें solid fuel you need to understand, ramjet you need to understand, duct you don't need to understand. Duct में the only thing you need to understand is that it produces less smoke because of that duct. That duct somehow allows it to produce less smoke and still propel forward. Propelling means going forward. Okay. Now, a jet engine is any engine that works on the principle of releasing things back like water or gases and going forward the way we have seen it in the air. Okay. Jet is that type of engine. So if I relate to a car, in cars we have internal combustion engines. Okay. So that is a jet engine. Jet also is doing combustion internally, releasing something back, and because of that thrust at the back, if I push something back, I will be able to move forward. This is Newton's third law called every action has an equal and opposite reaction. If I do an action back, I will move forward. This is a jet engine. Okay. Now jet engine are of many types. Okay. Jet engine are of many types. Like car engine, the basic principle is the same, that it will use petrol or diesel and it will generate energy that will move the car forward. This is the basic principle of a car engine. But car engines are of many types. Some is 1.6 liter engine, 1.8 liter engine, etc. Okay. So this is jet engine. Jet engine can have many types. One of the types of the jet engine is a ramjet engine. Okay. Now what is a ramjet? For any engine to be successful, it needs two things. It needs fuel like petrol, and it needs oxygen, which is an oxidizer. Without oxygen, burning cannot happen. So the engine has to obtain oxygen or oxidizer. A ramjet engine is trying to obtain this oxygen from space, from the air. Okay, from the air it is trying to get this oxygen. Now the problem is that air contains only 21% oxygen. So to get a decent amount of oxygen, get a high amount of oxygen, I will need more air. More air molecules will be needed, because 21% is what? 21% is 1 by 5. So if there are 5 air molecules, only one of them is the oxygen molecule. So I need to get more oxygen molecules. So I need to get more air molecules. Now, if I compress the air, if I bring it close like this, the air molecules will come close. So if I compress air, let's say air was in this tube, right? It had these many molecules. If I compress this tube using a piston, if I do something like this, all of these molecules, like there is a piston, I push it like this, all of these molecules will get packed here. Okay. So from this much, whatever oxygen I am getting, here also the same oxygen will be there. Here, let's say there are 2 molecules of oxygen. If I compress it, here also there will be 2 molecules of oxygen. But I will be requiring to take much less air, right? And if I am comparing, then the amount of oxygen I am getting in compressed air, very less. Even this much air is giving same oxygen, even this much air is giving same oxygen. So it is better for me to take this much air, right? Because then my capacity to take air will increase, right? My capacity to take air is increasing. Let's say my engine only has the capacity to take in this much air, or I'll use a different color. Let's say my engine only has the capacity to use this much air. So if I compress it here, I will get more oxygen, right? Now, how do I compress the air? The way to compress the air is to push into it. So what a ramjet is doing? A ramjet, the word ramming matlab, ram means to hit something really hard. To hit something really hard means to ram it. So what here I was doing, मैं air को बहुत तेज hit कर रहा था, ऐसे मार रहा था, compress कर रहा था. So a ramjet engine, it is a type of jet engine, meaning it will release something back to get forward. It is a type of jet engine. Now what is the specialty of ramjet engine? It rams the air, it hits the air really hard in front of it. If it hits the air in front of it really hard, what will happen? The air will get compressed. Then ramjet engine has a method. Ramjet engine has a method to take in this air. Okay, it needed an oxidizer, it had fuel, it needed an oxidizer, it wanted oxidizer from the air. So what it did, it rammed into the air, compressed the air, then the compressed air came in. Okay, then the compressed air came in. When the compressed air came in, it used the compressed air, had some oxygen, so it used the oxygen in the compressed air to oxidize its fuel and generate energy. This energy then carried the ramjet engine forward. Now, if it has to compress air, अगर उसे air को compress करना है, तो कुछ particular speed पे चलना पड़ेगा. अगर वो ऐसे चल रहा है, तो air compress नहीं होगी. एक particular speed पे चलेगा, तब air compress होगी. एक certain speed achieve करेगा, तब air compress होना शुरू होगी. इतनी कि it is enough to burn this fuel. उसे इतने इस लेवल का कंप्रेशन चाहिए कि जब वो ये कंप्रेशन करे तो इतने ऑक्सीजन मॉलिक्यूल आ जाएं कि वो फ्यूल बर्न करने के लायक हों. और ये कैसे डिसाइड होगा कि इट इज गेटिंग इनफ एयर? हाउ विल इट बी डिसाइडेड इफ इट हैज इनफ एयर? दैट विल बी डिसाइडेड थ्रू इट्स स्पीड. इफ इट इज गोइंग फास्टर, it will be able to compress more air. If it is going slower, air will not be compressed. This will compress air, this will not compress air. Understood? Now, इसका मतलब है कि एक पर्टिकुलर स्पीड है, उस पर्टिकुलर स्पीड पे, at that particular speed, if it works, it will get the amount of air required to burn the fuel. If it goes too fast, then also it will not work. If it goes too slow, then it will not work. Too slow is clear. Too slow mein to it will not even get the compressed air. If it goes too slow, it will not get the compressed air. But if it goes too fast, what will be the problem? The air will pass by very quickly, right? The air will pass by very quickly. समझ रहे हो? तो now there is a optimal speed. Optimal meaning ideal. Ideal मतलब जो बढ़िया जिस पे वो काम कर सकता है, राइट? ऑप्टिमल स्पीड, एक सही स्पीड जिस पे वो काम कर सकता है. देयर इज एन ऑप्टिमल स्पीड. इसी ऑप्टिमल स्पीड पे द इंजन वर्क्स प्रॉपर्ली. ओके, इन अ रैमजेट, रैमिंग इंजन of a jet type, the optimal speed is what? Mach 3 to Mach 6. From 3 times the speed of sound to 6 times the speed of sound. उसके engine के हिसाब से it is neither too fast, neither too slow. Clear? So this is the optimal speed. Why only this? Why cannot it go beyond this? इससे कम में क्या होगा, इससे ज्यादा में क्या होगा? If the optimal ideal speed is Mach 3 to Mach 6, less than Mach 3 to Mach 6, what will happen? In less speed, it will not get compressed air. The air compression will not be enough. Air इतनी compress नहीं हो पाएगी कि fuel जल सके. Above Mach 3 to Mach 6, what will happen? If it goes faster than its optimal speed, the air will be compressed too quickly. बहुत ज्यादा compress हो जाएगी. इतनी quick भी नहीं चाहिए उसको. उसको एक आइडियल स्पीड चाहिए. एक्चुअली उसको क्या चाहिए अंदर? उसको चाहिए कि अंदर जो एयर आ रही है वो उस एयर की स्पीड, नॉट जेट की स्पीड, m ऑफ एयर, स्पीड ऑफ एयर मस्ट बी लेस देन 1. मार्क ऑफ एयर एंटरिंग इट मस्ट बी लेस देन 1. खुद की स्पीड नहीं, खुद की तो कितनी भी हो, जो एयर एंटर कर रही है दैट शुड बी मार्क एयर शुड बी लेस देन 1 इन अ रैमजेट. यहां तक समझ आ रहा है? ऑप्टिमल स्पीड इतनी है, इससे कम में क्या होगा? एयर नहीं मिलेगी. इससे ज्यादा में क्या होगा? एयर को यूज नहीं कर पाएगा. सो क्या चाहिए उसको? ये ऑप्टिमल स्पीड. इस ऑप्टिमल स्पीड पे क्या होता है कि एयर जो उसके अंदर घुसती है, खुद की स्पीड छोड़ दो, forget about the speed of the jet, the air that enters it is entering at this speed. So air speed is what? Subsonic. Sub means less than sound. Air in a ramjet is subsonic. The ramjet itself is supersonic. This is its ideal speed. Less than that it can't work, more than that it can't work. What was happening? Can I say that in a ramjet, what is happening is the speed of ramjet. In a ramjet, what is happening is, can I say that ramjet moves at supersonic speed at subsonic combustion? सबसोनिक कंबशन क्यों कह रहा हूं मैं? बिकॉज एयर की एंट्री की स्पीड इज लेस देन माक 1, राइट? सबसोनिक कंबशन इज हैपनिंग इन रैमजेट, इट्स एक्चुअल स्पीड इज सुपरसोनिक. क्लियर? दिस इज व्हाट इज रैमजेट. नाउ एक मैंने बात बोली थी कि इट रिक्वायर्स एन असिस्टेड टेक ऑफ. असिस्टेड टेक ऑफ. व्हाई इट रिक्वायर असिस्टेड टेक ऑफ? It requires assisted takeoff because it can work properly only at this speed. To reach this speed, it needs an assist. पहले यहां तक पहुंचेगा ना, it cannot start, it will start from zero only. जीरो पे स्टार्ट होके यहां पहुंचेगा, तो जीरो से यहां तक पहुंचने के लिए it requires an assist. यहां पहुंचने के बाद it can work. This is a ramjet. Ramjet was सुपरसोनिक स्पीड एट सबसोनिक कंबशन. अब इसकी स्पीड में मार्क 6 से ऊपर क्यों नहीं बढ़ा पा रहा? बिकॉज ऑफ द सबसोनिक कंबशन, बिकॉज इट नीड्स कंबशन टू हैपन एट सबसोनिक लेवल. क्लियर? सो व्हाट इज द लिमिटिंग पॉइंट हियर? हम रुक क्यों रहे हैं? वी आर स्टॉपिंग बिकॉज ऑफ सबसोनिक कंबशन. ओके, तो अब इफ आई कैन डेवलप सुपरसोनिक कंबशन हियर, अगर मैं एक ऐसा डेवलप कर लूं जो सुपरसोनिक कंबशन पे काम कर जाए, तो और स्पीड बढ़ जाएगी. दैट इज स्क्रैमजेट. द वर्ड स्क्रैमजेट, इट इज अ टाइप ऑफ जेट. इट इज रैमिंग इनटू द एयर, बट इट इज एबल टू डू इवन सुपरसोनिक कंबशन. ये सुपरसोनिक कंबशन भी कर लेता है. तो SC जो है ना ये स्क्रैमजेट में, दिस स्टैंड्स फॉर सुपरसोनिक कंबशन ओनली. सुपरसोनिक कंबशन रैमजेट. ये देखो, सुपरसोनिक कंबशन रैमजेट. तो अब जब ये सुपरसोनिक कंबशन करने के केपेबल हो गया, तो इसकी जो ऑप्टिमल स्पीड है वो बढ़ जाएगी ना. तो इसकी ऑप्टिमल स्पीड मार्क 8 तक होती है, राइट? तो अब अगर मुझे किसी को मार्क 8 पे चलाना है, ये क्या है? हाइपरसोनिक है. ये हाइपरसोनिक मींस मार्क नंबर ग्रेटर देन 5. तो अगर मुझे किसी को हाइपरसोनिक पे चलाना है, तो इट्स बेटर टू यूज दिस इंजन. मार्क 7 पे भी चल जाएगा, मार्क 8 पे भी चल जाएगा. तो हाइपरसोनिक मिसाइल्स आर क्रिएटेड यूजिंग स्क्रैमजेट इंजन बिकॉज इट इज एबल टू डू सुपरसोनिक कंबशन. इट कैन वर्क इवन एट दिस लेवल. क्लियर? आपको याद क्या करना है? आपको याद करना है, और ये वन पेजर में कल इसलिए मैं आपके साथ रिवाइज करना चाह रहा था. You just need to remember what speed ramjet works at, what speed scramjet works at. इससे ज्यादा कुछ नहीं, राइट? एंड थोड़ा सा आइडिया आपको हो कि यहां सुपरसोनिक कंबशन हो रही है. ओके, सुपरसोनिक कंबशन रैमजेट, स्क्रैमजेट हो गया. अब आता है सॉलिड फ्यूल डक्टेड रैमजेट. सॉलिड फ्यूल क्या होता है मैं बताऊंगा. आई हैव नॉट टोल्ड यू येट. रैमजेट टेक्नोलॉजी तो पता है. इसमें हमने एक डक्ट लगा दी है, एक डक्ट लगा दी है जिससे स्मोक कम हो जाए. तो इसे हम कहते हैं सॉलिड फ्यूल डक्टेड रैमजेट. हम ये क्या पढ़ रहे थे? हम ये पढ़ रहे थे रॉकेट. रॉकेट इज अ कार फॉर अ सैटेलाइट. तो मिसाइल क्या होती है? मिसाइल होती है कार फॉर अ बॉम्ब. बात तो कार, बट वी आर रीडिंग दिस ओनली ना. वी आर रीडिंग दिस ओनली. अंदर में कुछ भी डालूं, मैं रॉकेट के अंदर बॉम्ब डाल दूं, मिसाइल बन जाएगी. मैं रॉकेट के अंदर सैटेलाइट डाल दूं, वो लॉन्च व्हीकल बन जाएगा, राइट? तो हम तो रॉकेट को पढ़ रहे हैं अभी. वी आर एक्चुअली रीडिंग रॉकेट साइंस. ओके, वी आर प्रॉपरली रीडिंग रॉकेट साइंस एट द मोमेंट. एंड ऑब्वियसली इट्स नॉट गोइंग टू बी इजी बिकॉज सब जब कहते हैं कि इट्स नॉट रॉकेट साइंस, इट्स नॉट दैट टफ, हम रॉकेट साइंस ही पढ़ रहे हैं. तो अब हमने क्या किया? सॉलिड फ्यूल छोड़ दो, ये बताता हूं. रैमजेट इंजन में एक डक्ट लगा दी जिससे कि स्मोक कम हो जाए. अब किसके लिए कर रहे हैं हम ये? फॉर मिसाइल्स. कैसे किया हमने? इंडो रशियन प्रोजेक्ट। ओके, नाउ इट इज सॉलिड फ्यूल्ड, ये छोड़ दो, एयर ब्रीदिंग तो पता है, रैमजेट पता है। अब इसकी जो रेंज है वो है 70 to 340 किलोमीटर। इस मिसाइल को ढंग से मारना है तो द टारगेट मस्ट बी बिटवीन 70 and 340 kilometers. This is not starting from zero. It does not say 0 to 340 kilometers because ramjet will have to attain certain speed. एक बार तो वो ऑप्टिमल स्पीड पे पहुंचेगा ना, तो अगर वो एक बार भी ऑप्टिमल स्पीड पे पहुंचेगा तो जीरो से स्टार्ट नहीं हो सकती है रेंज। दैट इज व्हाट आई वाज ट्राइंग टू एक्सप्लेन। जब वो एक बार ऑप्टिमल स्पीड पे पहुंच जाएगा फिर हिट करेगा तो कुछ तो उसकी मिनिमम रेंज भी होगी, रादर देन वो बिल्कुल पास वाले टारगेट पे आप यूज नहीं कर सकते, आपको उसे पहुंचाना पड़ेगा उस ऑप्टिमल स्पीड पे। ये समझ आ गया? इसके बाद एक चीज बची थी जो इस स्लाइड के पीछे है, उसमें लिखा था ड्यूअल मोड, ड्यूअल मोड रैमजेट। ये क्या था कि इसमें सबसोनिक कंबशन भी हो जाती है, मतलब ये रैमजेट की तरह भी काम कर सकता है। आप अपनी स्लाइड में देख लो, आई हैव ड्रॉन दिस बैकग्राउंड, तो वो आएगी नहीं, यू कैन सी इन द स्लाइड्स। इट कैन डू सबसोनिक कंबशन, सो इट कैन वर्क एज रैमजेट आल्सो। इट कैन डू सुपरसोनिक कंबशन, इट कैन वर्क एज स्क्रैमजेट आल्सो। तो अब ये क्या करेगा? हमने सिर्फ सीधा स्क्रैमजेट ही क्यों नहीं बनाया? हमने ऐसा क्यों बनाया? बिकॉज दिस इज मच चीपर। तो हम क्या करते हैं, मार्क 3 तक तो भाई सबसोनिक कंबशन वाला इंजन चलने देते हैं, कम पैसे लगते हैं। एंड व्हेन वी गो बियॉन्ड मार्क 4, मार्क 5, मार्क 6, मार्क 7 हमें पहुंचना है, तब हम ये वाला इंजन यूज करना स्टार्ट कर देते हैं। मार्क 4 टू मार्क 8 में इट बिकम्स अ स्क्रैमजेट, उससे पहले इट बिकम्स अ रैमजेट। क्लियर? आई होप इट्स डन नाउ। आई कैन नॉट मेक इट मोर क्लियर देन दिस। अब आते हैं फ्यूल्स। हम क्या कर रहे थे? प्रोपल्शन। प्रोपल्शन मींस गोइंग फॉरवर्ड। प्रोपल्शन करने के लिए पहला कंपोनेंट था इंजन। कार में क्या है? इंजन। और कार में क्या डालते हो आप? फ्यूल डालते हो, पेट्रोल, डीजल, है ना? यू पुट फ्यूल। ये फ्यूल क्या है? दिस फ्यूल इज व्हाट वी आर स्टडीइंग नाउ। अब आपको थोड़ा कार के बियॉन्ड सोचना है। कार में तो दो ही तरह के लिक्विड फ्यूल डलते हैं, बट इन रॉकेट्स देयर आर मेनी मेनी टाइप्स ऑफ फ्यूल। ओके, फर्स्ट टाइप ऑफ फ्यूल इज सॉलिड। सॉलिड फ्यूल मींस व्हाट? दैट द फ्यूल विल बी सॉलिड, ऐसा होगा। इट विल बी लाइक, मतलब solid, it like, let's say it's like a particle of cheese, for example. If you burn cheese, right, even then energy will be released. So that is like solid fuel. Most easy example of solid fuel is coal. Coal is a fuel and it is solid. तो रॉकेट में जो सॉलिड फ्यूल यूज होता है, किसी रॉकेट में मान लो सॉलिड फ्यूल यूज हो रहा है, तो उसे क्या, उस फ्यूल का नाम ये है HTPB, हाइड्रोक्सी टर्मिनेटेड पॉलीब्यूटाडायोन। बिल्कुल भी याद करने की जरूरत नहीं है, बस याद करो कि सॉलिड फ्यूल हो सकता है, कोल है ये, राइट? इट इज द सॉलिड फ्यूल। इसकी एडवांटेज क्या है? इट कैन बी इजी टू स्टोर। क्यों करें हम सॉलिड फ्यूल यूज? स्टोर करना आसान है और एनर्जी ज्यादा देता है ये, इट गिव्स मोर एनर्जी। तो रॉकेट की कुछ स्टेजेस होती हैं जो हम अभी देखेंगे। फर्स्ट स्टेज में हमें अर्थ से उठाना है रॉकेट को, तो सबसे ज्यादा ग्रेविटी लग रही है, अब जंप करो, राइट? तो आपको ग्रेविटी पुल डाउन करेगी, तो इस टाइम पे मुझे एनर्जी चाहिए टू गो अगेंस्ट दैट ग्रेविटी। उस टाइम पे आई एम यूजिंग सॉलिड फ्यूल। सॉलिड फ्यूल में एनर्जी ज्यादा है तो मैं शुरू में यूज करता हूं एंड इट इज इजी टू स्टोर। बट मैं हमेशा ही क्यों सॉलिड फ्यूल नहीं यूज कर सकता? व्हाई डोंट आई ऑलवेज यूज सॉलिड फ्यूल? बिकॉज वन, इट इज हैवी, सॉलिड्स आर हैवी, सो आई हैव टू पुट द फ्यूल ऑन द रॉकेट, राइट? एयर चलो मैं बाहर से ले लूं तो ले लूं, बट फ्यूल तो मुझे रॉकेट पे रखना पड़ेगा ना, तो इट इज हैवी। सेकेंड, इट डज नॉट बर्न यूनिफॉर्मली। व्हाई? लेट्स अंडरस्टैंड दैट। ये एक सॉलिड फ्यूल है, इसमें आप कहीं भी एक सर्कल बना के आग लगा लो, आप ट्राई कर लेना। आप मान लो सेंटर में आग लगाओ, तो ये सर्कल ही बड़ा होगा। जब ये सर्कल बड़ा होगा तो ये यहां पहुंच जाएगा, ऐसा। ये वाला पार्ट अनबर्न रह जाएगा, ये वाला पार्ट अनबर्न रह जाएगा, ये अनबर्न रह जाएगा, ये अनबर्न रह जाएगा। आप कहीं से भी सर्कल बना लो एक सॉलिड में, लाइक अ स्क्वायर, इफ यू ट्राई टू मेक अ सर्कल, कभी भी वो पूरे को कैप्चर नहीं कर पाएगा। एंड ये सॉलिड है तो इसकी शेप तो चेंज नहीं हो सकती। If it is water, let's say, I can change the shape, so I can burn it properly. It's not possible to burn water, just giving an example. Let's say there's petrol, I can change the shape, so I can burn it completely. but here I cannot burn it completely. Some part will be left unburned, or at the minimum it will be non-uniform. Non-uniform मतलब वो पूरी तरह से equally burn नहीं होगा, कुछ कुछ part छोड़ देगा. It will be non-uniform. This is solid fuel. Okay, ये इसकी एक disadvantage है. Second इसकी disadvantage है कि ये heavy है. अब देखते हैं liquid fuel. Liquid fuel is UDMH. ये इसका नाम है, unsymmetrical dimethyl hydrazine. अगेन बिल्कुल भी याद करने की जरूरत नहीं है, फुल फॉर्म. नाम अगर UDMH याद हो जाता है तो हो जाता है, बट इवन दैट्स ओके. दिस इज ऑल्सो यूज्ड इन PSLV एंड GSLV. इसमें फायदा क्या है? लिक्विड को तो आप यू कैन चेंज इट्स शेप, राइट? सो इट्स यूनिफॉर्म बर्निंग, सो इट हैज अ ग्रेटर efficiency. In this case only, if there was solid fuel, if I have a liquid fuel, I can first put it in a circular chamber. If I put it in a circular chamber, तो इसकी शेप लिक्विड की ऐसी हो जाएगी, फिर मैं बर्न करूंगा तो इट विल बर्न यूनिफॉर्मली. करेक्ट? तो ये हो गया एक एडवांटेज. दूसरा, लिक्विड की जो वेट है वो डेफिनेटली कम है, तो द रॉकेट विल बी चीपर, है ना? लिक्विड्स आर लेस वेटी, राइट? प्रॉब्लम क्या है? स्टोरेज. सॉलिड स्टोर करना आसान है, बिकॉज सॉलिड की शेप चेंज नहीं होती. लिक्विड की शेप चेंज हो जाती है, तो अगर आपके कंटेनर में छोटा सा भी क्रैक है तो लिक्विड उससे बाहर निकल जाएगा, राइट? दिस इज एडवांटेज एंड डिसएडवांटेज ऑफ सॉलिड फ्यूल वर्सेस लिक्विड फ्यूल. अब सॉलिड फ्यूल डक्टेड रैमजेट याद करो. वो एक ऐसा रैमजेट इंजन होगा जिसमें सॉलिड फ्यूल होता होगा. विच इज द नेम ऑफ द सॉलिड फ्यूल? HTPB. इफ इट वाज अ लिक्विड फ्यूल रैमजेट, इट वुड बी कॉल्ड UDMH. ये वाला फ्यूल यूज होता होगा. किस टाइप का फ्यूल यूज होता है? सॉलिड फ्यूल, जैसे कोल यूज करता है वो, या पेट्रोल यूज करता है, इतना ही है. अब पढ़ते हैं थर्ड टाइप ऑफ फ्यूल कह लो या टाइप ऑफ इंजन कह लो, कॉल्ड क्रायोजेनिक इंजन. अब एक बात याद रखो, ये वर्ड है क्रायो. क्रायो मींस वेरी लो टेम्परेचर. वेरी लो टेम्परेचर इज क्रायोजेनिक. वेरी लो टेम्परेचर. एक बार एक क्वेश्चन आया था मींस में, व्हाट इज द क्रायोस्फीयर एंड हाउ इज क्लाइमेट चेंज अफेक्टिंग इट. तो क्रायोस्फीयर क्या था? इट वाज द आर्कटिक एंड एंटार्क्टिक रीजन्स, प्लेसेस वेयर द टेम्परेचर इज वेरी लो. क्रायोजेनिक इंजन क्या है? क्रायोजेनिक इंजन ऐसा इंजन है विच स्टोर्स द फ्यूल. इसमें जो फ्यूल है वो स्टोर किया जाता है एज लिक्विड एट वेरी लो टेम्परेचर. वेरी लो टेम्परेचर मतलब -253 डिग्री सेंटीग्रेड या -183 डिग्री सेंटीग्रेड. इतने लो टेम्परेचर पे वी स्टोर द फ्यूल इन अ क्रायोजेनिक इंजन. ओके, अब विच इज द फ्यूल? क्रायोजेनिक इंजन में दो चीजें होंगी ना, एक तो फ्यूल होगा, एक होगा ऑक्सीजन, राइट? ऑक्सीजन मतलब ऑक्सीडाइजर. तो एक चीज स्टोर होती है ऑक्सीजन 90 केल्विन पे. केल्विन इज अ यूनिट ऑफ टेम्परेचर. केल्विन is a way to measure temperature the way centigrade is. So 90 Kelvin equals -183 डिग्री सेल्सियस. ओके, तो ऑक्सीजन जो ऑक्सीडाइजर है वो इसमें स्टोर हो रहा है -183 डिग्री सेंटीग्रेड पे. और जो हाइड्रोजन है, जो फ्यूल क्या है इसमें? हाइड्रोजन. हाइड्रोजन इज बीइंग स्टोर्ड एट व्हाट टेम्परेचर? -253 डिग्री सेंटीग्रेड. अब कमाल की बात यह है कि इवन एट दिस टेम्परेचर these two things can burn and interact and generate a lot of energy. So it generates high energy. Even at this temperature, hydrogen can burn. Ab, when this combination is burnt, it generates energy. So ये क्या है? Fuel. Hydrogen is the fuel. Oxygen is the oxidizer. What will be the engine called? Cryogenic. Why? Because it is at a very low temperature. So hydrogen is, अब हम क्यों यूज कर रहे हैं इसको? Why are we using this? Because hydrogen का जब मैं ऑक्सीजन से रिएक्शन कराता हूं तो क्या बनता है? वाटर. सो दिस इज एनवायरमेंट फ्रेंडली ऑल्सो. तभी तो ग्रीन हाइड्रोजन पे हमारा इतना काम चल रहा है, हाइड्रोजन व्हीकल्स पे इतनी बात हो रही है, बिकॉज दे आर एनवायरमेंट फ्रेंडली. उन्हें आप बर्न कराओ, ऑक्सीजन से इंटरेक्ट कराओ, वाटर प्रोड्यूस होगा, कोई गैस नहीं निकलेगी, लाइक कोई ग्रीन हाउस गैस नहीं निकलेगी, राइट? ओके, ऑल्दो इवन वाटर वेपर इज अ ग्रीन हाउस गैस, बट विल गेट इनटू दैट लेटर. ठीक है, तो हाइड्रोजन अबंडेंट है, एनवायरमेंट फ्रेंडली है, कार्बन डाइऑक्साइड नहीं निकल रही, abundantly hydrogen is available. अब यहां पे दो क्वेश्चन आएंगे कि मैंने लिक्विड की तरह क्यों स्टोर किया ऑक्सीजन और हाइड्रोजन को? मैं गैस की तरह ही स्टोर कर लेता, मैं गैस का इंजन बना देता. क्यों नहीं किया? अगर मैं गैस की तरह स्टोर करता, अगेन गेट बैक टू द कंप्रेशन एंड द वे गैस वर्क्स. गैस इज दिस, इतनी दूर है, अगर मैं इसको कूल कर दूं, नीचे टेम्परेचर पे लेके इसी चीज का मैं वाटर बना दूं, जैसे वाटर वेपर से अगर मैं वाटर लिक्विड बना दूं, तो द मॉलिक्यूल्स विल कम टुगेदर। तो इसमें मुझे इतना बड़ा टैंक चाहिए होता फ्यूल के लिए, अब इतने से टैंक से भी काम चल जाएगा। तो मैंने कूलिंग यूज करके हाइड्रोजन को भी लिक्विड बना दिया, ऑक्सीजन को भी लिक्विड बना दिया। इफ यू कूल हाइड्रोजन एंड ऑक्सीजन बियॉन्ड अ पॉइंट, दे विल बिकम लिक्विड्स। द वे इफ यू कूल वाटर वेपर बियॉन्ड अ पॉइंट, it will become water. Okay, so hydrogen and oxygen are stored as liquid. Why? Because if they were stored as gases, it would require a huge container. Now why oxygen and hydrogen, why not anything else? Because this is the highest efficiency combination possible. इनको बर्न करके जितनी एनर्जी निकलती है पर यूनिट वेट, 1 kg हाइड्रोजन और 1 kg ऑक्सीजन को अगर मैं साथ में बर्न करता हूं, और दुनिया में कोई ऐसा फ्यूल नहीं है जो 1 kg में ही इतनी एनर्जी निकाल दे। देयर इज नो अदर फ्यूल दैट हैज सिमिलर एफिशिएंसी। Okay, it provides best thrust per kilogram. This is done. Okay, and now one thing is important, that India has developed its indigenous cryogenic engine. Our ISRO scientists have done a remarkable job and we have our own cryogenic engine. Okay, हमारे पास खुद का cryogenic engine है. Now why did we build an indigenous cryogenic engine? Because we were not able to import the cryogenic engine from abroad because of American obstructionism. American obstructionism, why was it there? Because we were not a member of the MTCR. ये चीज मैं आपको समझाऊंगा अभी, before that I'll ask you some questions. क्या था प्रॉब्लम? अमेरिका कह रहा था इन लोगों को क्रायोजेनिक इंजन मत दो, क्योंकि ये मिसाइल टेक्नोलॉजी कंट्रोल रेजिम के मेंबर नहीं है। क्यों कह रहा था अमेरिका ये? बिकॉज अ रॉकेट इज द सेम डिजाइन एज अ मिसाइल। रॉकेट में बॉम्ब लगा दोगे तो वो मिसाइल बन जाएगा। इफ वी हैड गॉटन क्रायोजेनिक इंजन, अब उस क्रायोजेनिक इंजन को मैं रॉकेट के लिए यूज करूं या उस क्रायोजेनिक इंजन को मैं मिसाइल के लिए यूज करूं, दैट इज माय चॉइस। तो अमेरिका सेड नो, दे आर नॉट मेंबर्स ऑफ एमटीसीआर, यू डोंट गिव इट टू देम। वी हैव बिकम मेंबर ऑफ एमटीसीआर ओनली इन 2016। उससे पहले वी वर नॉट मेंबर्स। ओके, yeah, I'm not sure of the exact year, but recently only we have become members. Before that we were not member. तो तब हमें अपना इंडिजिनस क्रायोजेनिक इंजन बनाना पड़ा। और क्या बढ़िया है क्रायोजेनिक इंजन में? व्हाट इज द गुड थिंग हियर? दैट इट हैज वेरी गुड एफिशिएंसी एंड इट इज एनवायरमेंट फ्रेंडली। नाउ देयर आर सम क्वेश्चंस फॉर यू। MTCR I have discussed, Missile Technology Control Regime. You tell me these three. What is Nuclear Suppliers Group and is India a member? This is question 1. What is Australia Group and is India a member? This is question 2. What is Wassenaar Agreement and is India a member? This is question 3. ये बताओ, देखते हैं आपने कितना IR पढ़ लिया। India is not member of NSG. This is Nuclear Suppliers Group. इसमें China is the main problem. Australia Group में India is member. Wassenaar Arrangement में India is member. Australia Group is for biological and chemical weapons. Wassenaar Agreement is for dual use technologies. ये क्या होता है? जब IR पढ़ेंगे मेरे YouTube पे तब बताऊंगा। ओके, अब बात करते हैं इंडिया के लॉन्च व्हीकल्स के बारे में। लॉन्च व्हीकल क्या है? रॉकेट। इट इज ओनली अ रॉकेट, राइट? तो अब हम पढ़ रहे हैं लॉन्च व्हीकल्स के बारे में। कौन से लॉन्च व्हीकल्स? इंडियाज लॉन्च व्हीकल्स। इंडिया हैड फर्स्ट हिस्टोरिकल व्हीकल्स, जो पहले सबसे बने उनका नाम था SLV एंड ASLV, सैटेलाइट लॉन्च व्हीकल एंड ऑगमेंटेड सैटेलाइट लॉन्च व्हीकल। बस नाम याद कर लो, हाउ दे वर्कड इज नॉट इंपॉर्टेंट। इंपॉर्टेंट वो हैं जो करंटली ऑपरेशनल हैं, जो हम अभी यूज करते हैं। जो हम अभी यूज करते हैं उसमें 3 तरह के हैं। एक है साउंडिंग रॉकेट, ये भी आपके लिए इंपॉर्टेंट नहीं है। Sounding rocket just means measurement taking rocket. We use this rocket to take measurement. So it is a sounding rocket. Sounding word in space technology means measurement. Every Wednesday in Thumba, we test a sounding rocket. Okay? इससे ज्यादा information is not important. जो main चीज है वो यहाँ है। what is PSLV, what is GSLV, what is polar satellite launch vehicle, what is geosynchronous satellite launch vehicle. हमने जब ऑर्बिट्स पढ़े थे, मान लो ये सन है, दिस इज द अर्थ, अर्थ का एक ऑर्बिट है अराउंड द सन, अर्थ ऐसे घूम रही है अराउंड द सन, इतना तो ज्योग्राफी में पढ़ा है, राइट? अगर एक ऑर्बिट है, अगर एक ऑर्बिट है इस तरह का, ऐसा, तो ये क्या है, अर्थ के ही इक्वेटर के आसपास या अर्थ के किसी एंगल के आसपास, तो इसे मैं क्या कहूंगा, जियोसिंक्रोनस ऑर्बिट, बिकॉज इट इज इन सिंक विद द अर्थ्स रोटेशन, राइट? ये हुआ जियोसिंक्रोनस ऑर्बिट, पढ़ चुके हैं हम। एक होता है सन सिंक्रोनस ऑर्बिट, ओके? व्हाट विल अ सन सिंक्रोनस ऑर्बिट लुक लाइक? A sun synchronous orbit would look like this, the way a polar orbit looks like, polar ऐसा, from one pole to the other pole. मैं इसे sun synchronous क्यों कह रहा हूं? Because it is in sync with Earth's revolution around sun, not in sync with Earth's rotation. अगर Earth ऐसी है तो ये orbit ऐसा है, like this. And आपको ये भी बताया था, ये many times ये क्रॉस करता है Earth को. This is a sun synchronous orbit or a polar orbit. Why polar? बिकॉज ये नॉर्थ पोल है, ये साउथ पोल है, ये दोनों पोल्स को टच करता है, तो इट इज अ पोलर ऑर्बिट। ऐसा होता है जियोसिंक्रोनस ऑर्बिट, ओके? ये हम पढ़ चुके हैं वैसे, ओके? अब दो तरह के लॉन्च व्हीकल है, एलवी मतलब लॉन्च व्हीकल। एक है पोलर सैटेलाइट लॉन्च व्हीकल, PSLV, वन इज पोलर सैटेलाइट लॉन्च व्हीकल, सेकेंड इज जियोसिंक्रोनस सैटेलाइट लॉन्च व्हीकल, GSLV। अब पोलर सैटेलाइट लॉन्च व्हीकल कहां ले जाता होगा सैटेलाइट को? पोलर ऑर्बिट में। पोलर ऑर्बिट इज लो अर्थ ऑर्बिट, तो इसमें क्या चाहिए होती होगी? कम एनर्जी चाहिए होती है। लो अर्थ ऑर्बिट है पोलर ऑर्बिट, है ना, ये हम पढ़ चुके हैं। पोलर ऑर्बिट इज लो अर्थ ऑर्बिट एट डिस्टेंस ऑफ बिलो 2000 किलोमीटर, राइट? जैसे कि we have put many satellites there, we'll discuss that. PSLV is a polar satellite launch vehicle, it puts satellite in the polar orbit, so and they are light satellites, so PSLV has less energy, right? It puts remote sensing satellite in polar sun synchronous orbit, remote sensing satellite in polar sun synchronous orbit, clear? What is GSLV? GSLV is a launch vehicle that has geosynchronous satellite, right? Geosynchronous satellite, so it puts satellite in the geosynchronous orbit, right? So it has more energy, it puts satellites much far. It can be used for heavier satellites also, because it has more energy. The GSLV can be used for heavier satellites, and it can be used for heavier communication satellites to be put in geosynchronous transfer orbit. This, what is geosynchronous transfer orbit? This also we know. If it can put the satellite in GTO and a heavy satellite in GTO, it will go to the geosynchronous orbit. It can also go directly to the geosynchronous orbit. तो इसमें ज्यादा एनर्जी है, इसमें कम एनर्जी है। पोलर सैटेलाइट पोलर ऑर्बिट के लिए, जियोसिंक्रोनस सैटेलाइट जियोसिंक्रोनस ऑर्बिट के लिए, ओके? अब इनकी वो देखते हैं कॉन्फ़िगरेशन। जो PSLV है, ये एक 4 स्टेज का रॉकेट है। 4 स्टेज मतलब 1 स्टेज मींस हाउ डिफरेंटली द फ्यूल इज बर्निंग। These are 4 fuel stages. एक और डिफरेंट स्टेज होती है जो हम कल पढ़ेंगे। This is 4 fuel stages. Okay? 4 fuel stages are there in PSLV. First stage में बताओ कौन सा फ्यूल यूज होगा? Tell me what fuel must be used in the first stage. This you have to tell me. Okay. Of course, it is a solid fuel. So what happens in PSLV? पहले solid fuel burn होता है first fuel stage में, then liquid, then solid, then liquid. This is a 4 fuel stage. Solid fuel, then liquid fuel, then solid fuel, then liquid fuel. ये ऐसे ही क्यों organized है? Not important at all. You just need to know that there is solid, liquid, then solid, liquid. Okay? The topmost box, यहाँ, ये. There are 5 boxes. पहला solid, then liquid, then solid, then liquid. Topmost में क्या है? Payload. Payload क्या होता है? For a rocket or a launch vehicle, what is the payload? A satellite. तो टॉप मोस्ट बॉक्स में हम क्या रखते हैं? सॉलिड। तो सॉलिड लिक्विड देन सैटेलाइट। पहले ये बर्न होगा, फिर ये बर्न होगा, फिर ये बर्न होगा, फिर ये बर्न होगा, तब तक ये ऑर्बिट तक पहुंच चुका होगा, वहां पे सैटेलाइट रिलीज हो जाएगी। दिस इज पोलर सैटेलाइट लॉन्च व्हीकल। व्हाट इज जियोसिंक्रोनस सैटेलाइट लॉन्च व्हीकल? इट इज ओनली अ 3 fuel stage, 3 fuel stage. Okay, first stage is solid, second is liquid, third is cryogenic. तभी 4 स्टेज की जरूरत नहीं पड़ रही, तब भी it has more energy, it has less fuel stages, still it has more energy. इसे हम कहते हैं GSLV because it has cryogenic engine. cryogenic में हमने क्या पढ़ा था? बहुत efficiency है, बहुत power है इस इंजन में, but बहुत advanced technology है than the others, as I'm sure you can understand. बिकॉज इतने कम टेम्परेचर पे भी आपने फ्यूल स्टोर करना है। अब इंडिया ने खुद का क्रायोजेनिक बना लिया है, तो हम जीएसएलवी भी ढंग से बना पाए, हम जियो सिंक्रोनस सैटेलाइट भी ला पाए, राइट। अब पीएसएलवी के कुछ वर्जन हैं, जीएसएलवी के भी कुछ वर्जन है, आपने सुना होगा पीएसएलवी सी, पीएसएलवी एक्सएल, तो वो क्या होता है वो हम देखेंगे अभी। और जीएसएलवी में आपने सुना होगा जीएसएलवी मार्क 1 मार्क 2, ये भी हम देखेंगे अभी, ठीक है। पीएसएलवी में ये जो बनाया था अभी आपके लिए, सॉलिड लिक्विड देन सैटेलाइट, दिस इज कॉल्ड द कोर ऑफ द रॉकेट। कोर मतलब मेन चीज रॉकेट की ये है, कोर ऑफ द रॉकेट। जीएसएलवी का भी ये क्या है? कोर, ठीक है। बट हम पीएसएलवी में समझते हैं, दिस इज द कोर ऑफ द रॉकेट। तो पहला होता है पीएसएलवी सी, मतलब पीएसएलवी ओनली दैट हैज अ कोर। पीएसएलवी सी ही मोस्टली हम यूज करते हैं, सुना होगा आपने, पीएसएलवी सी मींस रॉकेट दैट हैज कोर। देन देयर इज अ स्टैंडर्ड कॉन्फ़िगरेशन। स्टैंडर्ड मींस कोर है बट कोर में इतनी पावर नहीं है कि एक लेवल तक पहुंच सके, तो मैं क्या करता हूं, मैं इसमें और इंजन लगा देता हूं, थोड़े छोटे छोटे, जस्ट बूस्टर्स, नॉट इंजन, बूस्टर, स्मॉल बूस्टर्स आई अटैच, तो दैट इज कॉल्ड स्टैंडर्ड कॉन्फ़िगरेशन विद 6 strap on boosters. Boosters mean they have been put on after the core. There was a core, इसके ऊपर मैंने 6 बूस्टर लगा दिए like this. So this is PSLV standard. Then there is PSLV extra large. Extra large मतलब again I have core, again I have 6 boosters like this, but ये जो 6 बूस्टर लगाए हैं इनमें ज्यादा एनर्जी है, ज्यादा फ्यूल है, so 6 strap on motors with more fuel capacity. This is PSLV extra large. PSLV core, PSLV standard, PSLV extra large. PSLV has 4 fuel stages, solid, liquid. Then it has satellite box at top. GSLV देखते हैं। GSLV क्या है? 3 स्टेजेस हैं इसमें। कौन सी 3 स्टेजेस? सॉलिड, लिक्विड, क्रायोजेनिक, 1 2 3। पहला वर्जन है इसका मार्क 1, यहाँ कोर भी नहीं होता, यहाँ वर्ड होता है मार्क। GSLV मार्क 1, GSLV मार्क 1 इज जस्ट द कोर, सिर्फ कोर। GSLV Mark II, I put 4 strap-on motors. तो GSLV Mark II। अब जो रिसेंटली बना है दैट इज GSLV Mark III। Mark III में क्या है? फर्स्ट स्टेज सॉलिड ही रहेगी, बट मैंने क्या किया, I'll just show you. I did something like this. The first stage is still solid, बट मैंने सॉलिड 2 इंजन लगा दिए, एक सॉलिड इधर, एक सॉलिड इधर। पहले ये सॉलिड बर्न होंगे ये वाले, फिर लिक्विड, फिर क्रायोजेनिक। दे आर कॉल्ड सॉलिड 200 बिकॉज इसमें 200 टन फ्यूल है, सॉलिड फ्यूल। सॉलिड 200 बिकॉज इसमें 200 टन फ्यूल है, तो 2 S200, ठीक है, 2 S200 सॉलिड 200, देन 1 लिक्विड 100, देन क्रायोजेनिक 25। और देखो क्रायोजेनिक में नंबर सबसे कम है, लीस्ट फ्यूल इज रिक्वायर्ड बिकॉज बहुत बढ़िया इंजन है। सॉलिड में हमने देखा था यूनिफॉर्मली बर्न नहीं होता, तो ज्यादा रिक्वायर्ड है। तो वी हैव सॉलिड 200, फर्स्ट दीज 2 विल बर्न, देन लिक्विड विल बर्न, देन क्रायोजेनिक विल बर्न। दिस इज GSLV Mark III, मोस्ट पावरफुल रॉकेट ऑफ इंडिया, GSLV Mark III, because it has cryogenic engine also, liquid also, solid also, and वहां the earlier version had only 1 solid, here we have put 2 solids. अब ये तो डायग्राम है, how does it actually look like? This is how it actually looks like. ये देखो, ये क्या है? ये है PSLV, इसमें आपको ये नीचे स्ट्रैप ऑन मोटर्स दिख रहे हैं छोटे छोटे, दिस इज PSLV स्टैंडर्ड, एक्स्ट्रा लार्ज भी हो सकता है अगर ये मोटर और बड़े होते तो। ये है GSLV Mark II, कैन यू सी 4 motors are attached at the bottom, then solid, then liquid, then cryogenic. GSLV Mark II. Then this is that final GSLV Mark III. It has two S200. Solid दो इधर दिख रहे हैं, दो बड़े बड़े S200, then liquid, then cryogenic, then at the top the India flag. ये हर जगह वहां होता है जहां अंदर सैटेलाइट होती है, because top पे तो सैटेलाइट होगी. पहले this will burn, like these two will burn, then the liquid will burn, then the cryogenic will burn, it will reach the orbit, then it will deliver the satellite. This is GSLV. Okay, all right. Process of Mark III यहाँ लिखा है, पहले solid 200 will burn, then liquid 100 will burn, then cryogenic will burn, and capacity of Mark III is 4 to 5 ton. And exact capacity हम आगे अभी देखेंगे. I'll draw a table for you, वहां पे आपको सारी capacity समझ आ जाएगी. Okay. GSLV Mark III. इस स्लाइड पे थोड़े से टाइपोज हैं, I made some mistakes, तो वो आप प्लीज चेक कर लेना. Only on this slide. GSLV Mark III. It is the heaviest launch vehicle of India. It weighs 640 tons. 640 tons कैसे? 200 plus 200 plus 110 plus 25. इतना तो फ्यूल का ही वेट है. ये सॉलिड, ये लिक्विड, ये क्रायोजेनिक, और कुछ जो अदर वेट होगा, राइट, और भी तो चीजें होंगी ना, मेटल वगैरह वगैरह. तो दिस इज 640 टन. ओके, इट कैन लॉन्च 4 to 5 टन सैटेलाइट. जितनी भारी सैटेलाइट लॉन्च करनी है उतनी ज्यादा एनर्जी लगानी पड़ेगी, उतना ज्यादा द इट नीड्स द कैपेसिटी. सो सिंस इट हैज मोर एबिलिटी टू जनरेट एनर्जी, it has more ability to generate energy, it will be able to use a heavier satellite. It is 42 meters long. 42 meter long. These data points are not that important, just a basic idea is important. Okay, heavy communication satellites that have to be put in geosynchronous orbit. Geosynchronous satellites can be delivered through this. We have read that it is in the geosynchronous that we are using communication, that we are using GPS, है ना. And it saves India's foreign exchange. Why? Because we don't have to rely on others to launch our satellite. Then it helps foreign exchange earning. It helps us to earn foreign exchange also, because we are getting foreign exchange from abroad, because they then give us our satellites and tell us, okay, put this in the geosynchronous orbit. Out of the international space market, currently we are earning only 1% of the revenue, because there are many other players. Even there are private players like SpaceX by Elon Musk, right? So if we develop this further, if we become even better, ISRO's only good thing right now is that it has less cost, but technology wise there are other countries that are doing better. So if we are able to develop good technology at low cost, we will earn a lot of foreign exchange. Okay, now PSLV is currently, it was in the news. Why? Because in its 55th mission, now you know what this means. In its 55th mission, it was able to deliver 3 Singapore satellites into the orbit. Now this was the second commercial mission of NSIL. NSIL stands for New Space India Limited. What NSIL is, what Antrix is, what InSpace is, this we will do tomorrow. But it was the second mission of PSLV, it was 55th mission of PSLV, and it was able to deliver 3 Singapore satellites. Other than that, ISRO has also achieved the successful launch of PSLV Orbital Experimental Module. We will see what this means in just the next slide. But PSLV clear है ना? Orbital Experimental Module, POEM, PSLV Orbital Experimental Module. ये क्या है? ये क्या है कि मान लो मैंने PSLV को लॉन्च किया. I launched the PSLV rocket. It had solid, then liquid, then solid, then liquid, then finally it had the satellite. Right? अगर मैं ऐसे लॉन्च करूंगा तो पहले solid burn हो गया, liquid burn हो गया, solid burn हो गया, liquid burn हो गया, then the satellite will go into the orbit. इसमें हमने क्या किया है in POEM, what we have done is that we now also have, यहाँ पे liquid fuel ऐसे burn होता है कि last वाला part जो है, where the payload box is there, where the satellite is there, this does not get discarded. This can be used for doing experiments in space. So the last satellite payload box, it can deliver satellite also, and it can be used as a platform for doing experiments in space. And we had read that in International Space Station we are doing microgravity experiment. So experiments in space is done by this platform. So this is PSLV orbital experimental platform, POEM, or exactly PSLV orbital experimental module. Clear? So this is what they have developed now, that the last final thing can be used for experiment. See, it allows in orbit inside the orbit scientific experiment to be done using the final fourth stage of PSLV. Using the liquid, it is burnt in such a manner that the orbital platform is not disrupted. It can be used for experiment. इसके अलावा इसमें क्या है? The platform itself has a command and control system. ये बात मैंने आपको बताई थी. It is like a car. तो इन्होंने प्लेटफॉर्म का भी अलग से एक कमांड एंड कंट्रोल सिस्टम बना दिया ताकि हम उसे कंट्रोल कर सकें. तब तो एक्सपेरिमेंट करेंगे ना जब उसे कंट्रोल कर सकेंगे. एंड इट हैज सोलर पैनल्स. व्हाई सोलर पैनल्स आर देयर? ये भी एक इंपॉर्टेंट क्वेश्चन है. व्हाई आर देयर सोलर पैनल्स इन स्पेस, इनसाइड, इन एन ऑर्बिट? What is the way for the satellite to get energy? The only way it can get energy is from the sun, right? So it is a solar panel powered experimental module. किसी सैटेलाइट पे भी आपने ऐसे देखा होगा, ऐसे विंग्स बने होते हैं. यहाँ पे सोलर पैनल ही होते हैं. इस सोलर पैनल से इट इज गेटिंग एनर्जी फ्रॉम द सन. ओके, तो ये समझ आ गया POEM क्या है. Now this is our launch vehicle. PSLV, GSLV Mark II, GSLV Mark III we have done. स्मॉल सैटेलाइट लॉन्च व्हीकल वी हैव नॉट डन. ठीक है, मैं अभी आपको एक ब्रीफ में बता देता हूं, फिर मैं डिटेल में बताऊंगा. यहाँ पे लिखा है 3 स्टेज लॉन्च व्हीकल है एंड इट हैज 3 सॉलिड प्रोपल्शन स्टेजेस. इट हैज 3 स्टेजेस, ऑल 3 आर सॉलिड. इट इज अ स्मॉल सैटेलाइट लॉन्च व्हीकल. टुमारो वी विल डू दिस इन डिटेल, बट नाउ यू शुड बी एबल टू अंडरस्टैंड व्हाट द डिफरेंसेस आर. एंड हियर इट इज रिटन इसकी क्या कैपेसिटी है. दिस यू रीड बाय योरसेल्फ. व्हाट इज द कैपेसिटी? एंड ऑब्वियसली द कैपेसिटी इज इंक्रीजिंग. उसका तो नाम ही स्मॉल सैटेलाइट है, तो कैपेसिटी सबसे कम होगी. PSLV, then GSLV Mark II, then GSLV Mark III. So capacity is increasing here. The capacity of course will be different for polar orbit and different for geosynchronous orbit. मान लो एक बहुत heavy satellite है जो मुझे polar orbit में डालनी है, तो I can do that only with GSLV Mark III. I think this is also clear. Okay, what did I say? I have a very heavy satellite that PSLV cannot carry. So ऐसा नहीं है कि GSLV जा नहीं सकता पोलर ऑर्बिट में. इट कैन गो, ऑफ कोर्स इट कैन गो, बट जनरली पोलर सैटेलाइट्स आर नॉट दैट हेवी. बट इफ दे आर, आई विल हैव टू यूज दिस, राइट? काफी बेसिक चीज है ये. ऑल राइट, नाउ वी आर टॉकिंग अबाउट रीयूजेबल लॉन्च व्हीकल विच इंडिया करंटली डज नॉट हैव. Somebody asked that when PSLVs come back, right, what happens is they drop in the sea. That is not reusable. What is happening is PSLV हवा में उड़ा, इसका सॉलिड पूरा बर्न हो गया. अब ये जो चीजें थी नीचे गिर गई इनसाइड द सी. फिर इसका लिक्विड पूरा बर्न हो गया, ये गिर गई इनसाइड द सी. ये रीयूजेबल थोड़ी है. दिस इज नाउ डिस्पोज्ड, इट्स वेस्ट. आई मेड 1 PSLV रॉकेट. इससे भी मैंने क्या किया? आई लॉन्च 3 सिंगापोरियन मॉड्यूल सैटेलाइट्स एंड आई लॉन्च द पोएम, राइट? बट नाउ दिस रॉकेट इज वेस्ट फॉर मी. इट्स डन. Reusable would mean that the rocket would come back. I can put more fuel and use the rocket again. That is a reusable launch vehicle. It looks like a winged aircraft. The way an aircraft looks, it looks like this. Winged aircraft, right? It uses boosters to go to orbit, right? It uses boosters to go to orbit. Then the wings, they detach. The wings detach and it is able to glide back to space. How it works is not important. Just if you understand it is a winged aircraft, this is enough. इसका डायग्राम मैं भी आपको दिखाता हूं. डायग्राम जो इसरो ने प्रपोज किया है. एंड नॉर्मल, when we have normal expendable launch vehicle, it will not come back. But here the reusable launch vehicle will come back. Okay, this is the diagram that is proposed by ISRO for a reusable launch vehicle. We currently do not have it. That is why I have written here proposed. See, it has certain wings. In the space, these wings will detach and it will come back. How this works is not important. And it is one more term that I want you to remember is it is a 2-stage to orbit vehicle. But to explain 2-stage to orbit to you, I will have to teach you physics for an hour. So I'm not doing that. Just remember 2-stage to orbit launch vehicle is a reusable launch vehicle. Okay, this much is done. बहुत कम चांस है कि प्रीलिम्स में पूछें. 2 things you have to remember and it's done. Now what would be the advantage Of course, you can understand the advantage of a reusable launch vehicle, right? We will earn foreign exchange. It will be less costly for us to do missions. एक ही rocket हम बार बार use कर लेंगे, right? Then we will capture the international space market. Again, the cost will be low, and this is greater technology. Then it can be used for space tourism also. Space tourism or a manned mission. Manned mission means mission that carries astronauts to space. Cannot be done on a PSLV, right? How will they come back? So for that you need this reusable vehicle. Okay. So these are the advantages. What are the challenges? वही challenges जो हर चीजों में होते हैं. Infrastructure is a challenge. Cost benefit. Should we invest in reusable launch vehicle or should we invest in hunger and poverty? Then logistic challenges, training challenges. So these are basics. Again, this is for this is not for prelims. The thing you need to know here is that since reusable launch vehicle is coming from space back to Earth, it has a lot of speed. So we require a 10-kilometer runway on the coast for this to work. This is important. A very long runway is needed. Okay, वो रुकेगा कैसे? So very, very long runway is there. 10-kilometer runway is needed at the coast. Minimum 10-kilometer runway is needed to stop a reusable launch vehicle. Okay, all right. Now let's come to the idea of space debris. देखो, this is how big the orbit is. Even bigger than this. This is one satellite. That is why no clash happens, right? Space debris, what does it mean? Space debris means that there is old or junk is present now in the orbits. I have certain orbits that I use, वहां पे junk इकट्ठा हो गया. Things have collected there that are not of my use anymore. They are debris that are in the orbit. This is space debris. Why was it in the news? Because Chinese rocket Long March 5B re-entered the atmosphere and it landed in the Indian Ocean, right? And many of its components fell in the Indian Ocean. But it created some space debris when they were building Tiangong. They were using this rocket to build further components of Tiangong, which is China's space station. क्यों न्यूज में आया is not important. Space debris होता क्या है, उसको हम हटाएंगे कैसे, that is important. Okay, so space debris, first important thing that you will definitely mark wrong in the prelims is that it is both natural and artificial. Okay, there can be natural space debris also. What could be natural space debris? Natural space debris could be meteoroids. Meteoroids orbiting the sun are space debris, unusable material in the Earth's orbit. Natural. Mostly they are in the sun's orbit, but they can be natural. ये important है. And they can be artificial also. Artificial obviously is satellites. When we send a satellite to space, initially it has a use. But after that, let's say after 8 years, the satellite is now no longer in use. There is no way for me to use the satellite. It's purposeless for me now. Then what do? It is space junk for me now. It is unusable. It is in the orbit. So it's a problem. This is what space debris is. So artificial can be satellite and natural can be meteoroid. Most of the debris is in low Earth orbit. But some debris is there here also. Why is most debris here? Because it's much easier to launch into low Earth orbit than it is to launch in geostationary orbit. More satellites have been launched into LEO, right? For geostationary, you require GSLV, you require cryogenic engine. For LEO, for low Earth, you did not require cryogenic engine, even PSLV was sufficient. So many countries have that ability to launch into LEO. So LEO had more satellites, so it has more debris. There are about 5 lakh pieces of debris the size of a marble. This small debris, about 5 lakh pieces are there. Now they are revolving around the Earth at very high speed. Now understand the problem. If this is what the orbit looks like, if you want to now launch a satellite, if any one thing also comes and hits your satellite, you are done for. So many years of effort, so much money is spent, and space debris, one small particle hits you. Because what is the speed at which it is moving? It is moving at speed of 17,000 miles per hour. 17,000 miles per hour it is moving. Small particle. If it hits your satellite is dead. So that is the problem of space debris. Now, international guidelines suggest that if you have spacecraft in LEO, right, the normal life of any satellite is close to 10 years. After 10 years, satellites, they stop working because there are issues and normal wear and tear. The way phones stop working after some time. So satellite, 10 years there is a life. So the guideline suggests that after 10 years, you move the satellite into some other orbit, leave it from the LEO, and you leave that orbit, right, so that others can come in. But most missions do not follow this guideline. Rather, only 60% follow. So 40% are not following these guidelines. This has led to lot of debris. Now, how do you tackle space debris? यहाँ पे दो टर्म मैं आपको बताऊंगा. एक होती है मिटिगेशन, एक होती है अडेप्टेशन. ये हम क्लाइमेट चेंज जब पढ़ेंगे तब भी आएगी और अभी भी आएगी. One is mitigating the damage, means stopping the damage. One is adapting to the damage. Adapting means whatever damage has happened, fine, I will adapt and I will learn to live with the damage. So in case of space debris, what does mitigating damage mean? These terms are used for climate change, but here also they are used. You track the space debris. Okay, you track the space debris, and what do? You say that, okay, you have an early warning that the debris could come and hit. So that is mitigating damage, and ISRO has developed Project Netra. What is Project Netra? It is a warning system that tracks space debris and says, okay, damage might happen. So move your satellite out. Satellite had a liquid apogee motor that we have seen. That is why it was being used for transfer orbit also. So you can move the satellite a little bit. All right. Then we are also developing this orbit computation of space objects for space situational awareness. For awareness of the situation of space, we are developing a new technology called orbit computation of resident space objects. देखो word breakdown. Orbit we know. Computation means calculation. Resident space objects. Resident means staying there. Space objects, objects in space. Objects in space that are continuously staying in the orbit, we are calculating them. If we calculate them, we will have an idea, okay, this is the amount of space debris. So I will need a satellite like this in this position, etc., etc. This is being developed by Indraprasth Institute of Information Technology. Okay. Now, what is the other way? You avoid the future debris. How do you do that? You use such a satellite that can come back itself into Earth, right? For example, there was UK's Tech Demo Sat-1. This is the name of the satellite. What happens is, once the mission is over, once the satellite has done its job, what does the satellite do? This is the Earth. This is the Earth's atmosphere, right? It will have some atmosphere, right? Satellite goes to this place. Once the mission is over and the satellite is no longer useful, it's done its job, it will drag back into the atmosphere. जब ये atmosphere में drag back होगी, because of the friction that the air offers and the high speed at which it will burn. मैं आपको एक experiment देता हूँ. You rub your hands close together, start rubbing them, and keep rubbing them. Keep rubbing them for 3 minutes. In 3 minutes, you will start feeling heat. आपसे होगा ही नहीं 3 minutes तक, because it will become so hot after some point because of friction, right? So we are using the same thing. We are dragging the satellite the way you are dragging your hands against each other. I am dragging the satellite in the atmosphere, outside atmosphere, not atmosphere close to Earth, not in the troposphere, not in the stratosphere, right? In the exosphere, in the ionosphere. At that place, even the burning or pollution does not affect me. So I drag it in that place. If I drag it in that place and I keep dragging it, it will burn. It will burn completely. So it will burn completely and there will be no debris. This will be brought back. So this is one way that UK has done in its Tech Demo Sat-1. Okay. Other way is to remove the debris. If you are confused about mitigation and adaptation, we will do it in detail when we do environment. You don't have to remember here. Okay. Then there is removal of debris. Removal of debris is that there is space debris, there is junk present. I remove it somehow. I send, let's say, a spaceship or a satellite that captures the debris and brings it back, or burns it. That will be removal of debris, right? Isme there is end of life services by astroscale demonstration, ELSA-D. Just remember the name, end of life services by astroscale demonstration. End of life matlab, whose end of life? The satellite's end of life. Satellite's purpose is over, so you give it the end of life. and you retrieve the used satellite and other space junk. Okay, this is one thing. Then there is remove debris project. This is by the European Union. European Union has remove debris project. Okay, all right. Now, what could be the possible techniques to remove debris? First would be that there is debris in the orbit. I actively remove it. Active means I use energy. I use energy to remove it. That would be active removal. Second would be deorbiting at end of life. That means it's in the orbit. I program it in such a way that when its mission is complete, it leaves the orbits and starts to burn, the way we have seen. That would be deorbiting. Third will be that, see, 35,786 kilometer orbit. This orbit at 35,786 kilometer. This is very useful orbit. We know this because this is geostationary and geosynchronous orbit. This is the height. Okay, this is very important orbit. But let's say 40,000 orbit. This is useless orbit, right? Neither it is geosynchronous, geostationary, neither it is close to the earth. So it is useless. So what can I do? I take the debris that is in 35,000 orbit. Let's say this is the earth, this is the geostationary geosynchronous orbit. I take the debris from here and I'm able to move it to 40,000 orbit. Even if it is there in 40,000 orbit, it's not a problem, right? Because that orbit is useless to me. So I could move the object into a less populated disposal orbit. Or I could have a way that it naturally burns. It naturally disintegrates and burns. This is orbital lifetime reduction. That is, I naturally let it burn. Naturally. Lifetime reduction into less populated orbits, I can move it. Actively, I can remove, capture it, or I could deorbit it. These are the 4 techniques. What are the methods? Isme how they work is not important. What is important? That net capture, harpoon capture, deorbiting, vision-based navigation, these things are connected with space debris. बस इतना याद रखना है. नेट कैप्चर समझ आ रहा है? हमने एक नेट लगाया, स्पेस डेब्री कैप्चर कर लिया. हार्पून कैप्चर, हार्पून ऐसा होता है, like it will go open like this, capture the space debris. Harpoon capture. Deorbiting we have already learned. And vision based navigation means I give the satellite some sort of vision, some sort of sensor that a space debris is coming to it, it is able to deviate like this. Okay, so this is vision based navigation. It is done using LiDAR. What LiDAR is, we'll read later. All right. Now, what is the way forward? Remove debris project of EU we have seen. There was a wide stork experiment done by JAXA, right? What they thought was that they will take a huge magnet into space, then that huge magnet will pull all the space debris. Then they will take the magnet into some other orbit. But this experiment failed. बस आइडिया दे रहा हूं आपको कैसे स्पेस डेब्री रिमूव हो सकता है. रिमूव डेब्री प्रोजेक्ट वी हैव सीन, हार्पून कैप्चर. देन आरएलवी जैसे हम है, रीयूजेबल लॉन्च व्हीकल है, ऐसे रीयूजेबल सैटेलाइट बना दो that it comes back after its mission is done. It deorbits, it has natural decay, so the debris will be reduced. Now there is an idea called Kessler syndrome. This is the last topic for today. There is an idea called Kessler syndrome. यार कल हम थोड़ा सा तेज चलेंगे, ठीक है? Because this is taking too much time. I understand today I had to explain ramjet, scramjet. Tomorrow there is no such explanation. It's only theoretical concept. Yeah, चलो, let's talk about this once we're done with Kessler syndrome. Kessler syndrome is this. एक स्लाइड में समझते हैं. एक स्पेस डेब्री के मॉलिक्यूल ने या एक पार्टिकल ने एक सैटेलाइट को हिट किया, सैटेलाइट टूट गई. अब इतने सारे वो बन गए स्पेस डेब्री के पार्टिकल्स. ये और सैटेलाइट्स को हिट करेंगे तो और ज्यादा होगा. तो जो आइडिया है एंटी सैटेलाइट वेपन का, एंटी सैटेलाइट वेपन इज आई यूज अ वेपन टू डिस्ट्रॉय द सैटेलाइट ऑफ सम अदर कंट्री. दैट इज ASAT, एंटी सैटेलाइट वेपन. दैट कैन लीड टू Kessler syndrome. And if Kessler syndrome happens, many satellites will be gone, and you can imagine what will be the impact on Earth, right? तो बस ये आइडिया अगर आपको पता हो, this is what Kessler syndrome means. From one, it will break into many. अब ये सारे space debris के parts बन गए, they will also break, and this will go on, right? There is the United Nations Office on Outer Space Activities. It is doing, it has made up a committee to investigate space debris. Okay, and obviously space debris that are of high speed, they are the most dangerous, right? What is Kessler syndrome? It is a cascade of collisions, chain reaction, collision after collision after collision. It is named after Donald Kessler. This is the person who was in NASA and he came up with this idea. That is why it was called Kessler syndrome. So we're done